What sets AIR2 and AIR3 apart in UPSC CSE 2024? They didn't wait to feel ready. They started smart with the GS Foundation course at Vision IS Delhi. Structured learning, focused current affairs, real mentorship, test feedback that actually helps you grow. This course isn't just about study hours, it's about direction, clarity and the strategy toppers trust. Start strong. Start where toppers started.
UPSC preparation is not just about reading books or watching online lectures. It requires personal guidance, real discussions, and structured practice. This is where offline mentoring makes all the difference. Unlike online learning, where doubts often remain unresolved, offline mentoring offers direct interaction, real-time feedback, and an environment of discipline and competition. One-to-one sessions help students get tailored advice, strategy corrections, and focused improvement. Every aspirant has different strengths and weaknesses. Personal mentoring helps address them effectively. Ground discussions sharpen analytical thinking and help students develop a multi-dimensional perspective on issues crucial for prelims, mains, and interview. Elocution sessions help in personality development, clarity of thought, and confidence, essential for UPSC interviews. Test writing is the most crucial part of UPSC preparation. It helps in time management, structuring answers, and improving content quality. Offline mentoring is not just about teaching. It's about grooming future officers with the right guidance, discipline, and confidence. So if you are preparing for UPSC, make sure you have the right mentor by your side.
Are you still juggling newspapers, random notes, and endless PDFs trying to make sense of current affairs? Let's make your UPSC prep smarter. Introducing Digital Current Affairs Premium by Vision IAS, your all-in-one platform to read, revise, and write better every single day. Have a doubt from today's news or something in your syllabus? Just ask and get instant AI-powered answers that are concise, relevant, and completely aligned with the UPSC exam pattern. No more guesswork, no more confusion. Want to boost your mains writing skills? Practice daily with structured questions and get expert feedback to sharpen your content, clarity, and analysis, because writing well is winning half the battle. Need better revision? Use quick notes and highlights to save key points, mark important lines, and organize your current affairs in a way that actually works for you. And here's the best part, some of the most powerful tools are absolutely free. Daily news summaries from The Hindu, Indian Express, and more, curated, filtered, and exam ready. Downloadable PDFs so your notes stay organized and accessible. Daily quizzes and MCQs to reinforce what you've learned and track your progress. A smart student dashboard to monitor your performance and stay on top of your goals. Whether you're just starting or deep into your prep, Digital Current Affairs Premium adapts to your strategy and makes every minute count. So why prepare the hard way when you can prepare the smart way? Visit www.visionis.in/current-affairs and start transforming your current affairs prep today. Because with Vision IAS, you don't just stay updated, you stay ahead. UPSC CSE 2024 results are out and dreams have turned into ranks. Now you are asking, how do I get there? You've got the drive. What you need is the right guidance. Lakshya Integrated Mentoring Program 2026 by Vision IAS is your one-stop guidance program for prelims, mains, and interview. Smart, strategic revision for prelims and mains. Consistent mentorship with personalized feedback. Daily weekly schedule and practice targets. Custom test practice via Sandhan test series. Interview and personality test training. All of it structured to guide you, strategic to keep you focused, and designed to meet your evolving needs. New batch starts from 19th May. It's your turn now. Start strong with Lakshya Mentoring Program 2026.
What sets AIR2 and AIR3 apart in UPSC CSE 2024? They didn't wait to feel ready. They started smart with the GS Foundation course at Vision IS Delhi. Structured learning, focused current affairs, real mentorship, test feedback that actually helps you grow. This course isn't just about study hours, it's about direction, clarity, and the strategy toppers trust. Start strong. Start where toppers started.
UPSC preparation is not just about reading books or watching online lectures. It requires personal guidance, real discussions, and structured practice. This is where offline mentoring makes all the difference. Unlike online learning, where doubts often remain unresolved, offline mentoring offers direct interaction, real-time feedback, and an environment of discipline and competition. One-to-one sessions help students get tailored advice, strategy corrections, and focused improvement. Every aspirant has different strengths and weaknesses. Personal mentoring helps address them effectively. Ground discussions sharpen analytical thinking and help students develop a multi-dimensional perspective on issues crucial for prelims, mains, and interview. Elocution sessions help in personality development, clarity of thought, and confidence, essential for UPSC interviews. Test writing is the most crucial part of UPSC preparation. It helps in time management, structuring answers, and improving content quality. Offline mentoring is not just about teaching. It's about grooming future officers with the right guidance, discipline, and confidence. So if you are preparing for UPSC, make sure you have the right mentor by your side.
Are you still juggling newspapers, random notes, and endless PDFs trying to make sense of current affairs? Let's make your UPSC prep smarter. Introducing Digital Current Affairs Premium by Vision IAS, your all-in-one platform to read, revise, and write better every single day. Have a doubt from today's news or something in your syllabus? Just ask and get instant AI-powered answers that are concise, relevant, and completely aligned with the UPSC exam pattern. No more guesswork, no more confusion. Want to boost your mains writing skills? Practice daily with structured questions and get expert feedback to sharpen your content, clarity, and analysis, because writing well is winning half the battle. Need better revision? Use quick notes and highlights to save key points, mark important lines, and organize your current affairs in a way that actually works for you. And here's the best part, some of the most powerful tools are absolutely free. Daily news summaries from The Hindu, Indian Express, and more, curated, filtered, and exam ready. Downloadable PDFs so your notes stay organized and accessible. Daily quizzes and MCQs to reinforce what you've learned and track your progress. A smart student dashboard to monitor your performance and stay on top of your goals. Whether you're just starting or deep into your prep, Digital Current Affairs Premium adapts to your strategy and makes every minute count. So why prepare the hard way when you can prepare the smart way? Visit www.visionis.in/current-affairs and start transforming your current affairs prep today. Because with Vision IAS, you don't just stay updated, you stay ahead. UPSC CSE 2024 results are out and dreams have turned into ranks. Now you are asking, how do I get there? You've got the drive. What you need is the right guidance. Lakshya Integrated Mentoring Program 2026 by Vision IAS is your one-stop guidance program for prelims, mains, and interview. Smart, strategic revision for prelims and mains. Consistent mentorship with personalized feedback. Daily weekly schedule and practice targets. Custom test practice via Sandhan test series. interview and personality test training. All of it structured to guide you, strategic to keep you focused, and designed to meet your evolving needs. New batch starts from 19th May. It's your turn now. Start strong with Lakshya Mentoring Program 2026.
What sets AIR2 and
but absolutely crucial. No matter how well you perform in GS, if you don't clear CSAT, your prelims ends there. Every year, many capable aspirants fall short simply because they underestimated this paper. What's the way forward? Structured preparation, consistent practice, and the right guidance. Join the Vision IAS CSAT Classroom Program 2026 starting from 12 June at 11 a.m. What you'll get: complete coverage of quantitative aptitude, logical reasoning, and comprehension. Emphasis on speed, accuracy, and concept clarity. regular practice with UPSC level questions, personalized guidance and mentorship, available in both offline, classroom, and live online modes. Whether you're a first-time aspirant or reappearing, don't let CSAT be the reason you fall short. CSAT is qualifying but absolutely crucial. No matter how well you perform in GS, if you don't clear CSAT, your prelims ends there. Every year, many capable aspirants fall short simply because they underestimated this paper. What's the way forward? Structured preparation, consistent practice, and the right guidance. Join the Vision IAS CSAT Classroom Program 2026 starting from 12th June at 11 a.m. What you'll get: complete coverage of quantitative aptitude, logical reasoning, and comprehension. Emphasis on speed.
Hello, good afternoon. Okay, so in the last two sessions, one of the session had questions about classical mechanics and relativity. And then in the second session, we did a discussion of quantum mechanics, questions of quantum mechanics. If you want to watch that, those two videos are available on YouTube. So you can watch those PYQs. In today's class, I'm going to pick the first topic of section B in paper 1, which is electricity and magnetism. So in today's class, we are only going to talk about electricity and magnetism. And again, same thing. We are going to discuss the questions asked by UPSC in last 3 years. And we are going to look at the solutions, and we are going to focus upon that how we could have improved our answer. Like knowing everything we know, what more can be written in the answer to get that extra 0.5 or 1 marks in each and every question. So we are going to look into those things also. Before I jump into the discussion part, I wanted to spend some time, a little bit time, in talking about the idea of electricity and magnetism itself. Because when you jump from, for example, when you study classical mechanics, in classical mechanics, the most important force you study is one of the central force, which is gravity. You learn about gravitational force. But gravitational force is a very unusual force, in the sense that gravitational force depends upon mass, and the acceleration due to gravitational force is often independent of mass. So for example, if I drop this watch and this pen, both of them are going to drop exactly with same acceleration due to gravity, only due to gravitational force. So it depends upon mass. All forces depend upon mass, and gravitational force as a force depends upon mass. Now why this is very unusual? Because no other force behave in that way. So when we look at electrical force, there is a property called charge, and due to that charge, objects can accelerate. You study the dynamics of charged particles in this entire branch of physics, which is called electrodynamics. But in case of gravitational force, your acceleration is essentially dependent upon mass itself. That while in other cases, so acceleration is dependent upon mass for all type of forces, but in this case, for example, I have two charged particles, Q1, Q2, and if I have to calculate the acceleration on Q1, then this is F by m, and that F by m will be Q1, Q2, 4 pi epsilon naught r square and m. So m comes as a separate term, but in gravitational force that Q1, Q2 becomes m1, m2, and m1, m1 cancels out, and I'm left with m2. So somehow my acceleration is not dependent upon my mass. It only depends upon the other mass and the distance between that. So this is very unusual about gravitational force. And that is why we still, by the way, we still do not know the exact nature of gravity. We know what it does, but we do not know what is gravity exactly. We do not even know if it is a force or not. I'm talking about if you have some very basic idea about Einstein's general theory of relativity, then you realize that maybe gravity is not even a force. It is simply a consequence of curvature in space-time. Now, thankfully for UPSC, you do not have to go into such details where you have to know about curvature of space-time. Coming to electricity and magnetism, how science develops. I always talk about that science relies upon maths. This is something which we do not understand really well, that why laws of nature are written in, are described with mathematical laws. Right, so physics relies upon maths, but physics is also not maths. I make that statement a lot. And electricity is a great example of that, that when electricity was discovered, this entire theoretical description, what electricity is, how it depends upon this property which we call charge, and it happens in two forms, positive and negative and all of that. And magnetism, which was discovered separately from electricity, and people thought that this is a new property we have discovered. And then in the course of time, people realized that no, it's not so. Magnetism is not very different from electricity. In fact, it is whenever charged particles are moving, they will produce a magnetic field. But there was a problem there also, that then people discovered permanent magnets. And permanent magnets which has no charge, chalo, even if internal charges are moving, but I still have a permanent magnetism. This was not resolved till the time Einstein gave his special theory of relativity. So the first, one of the most remarkable thing about magnetism one should know, that you cannot appreciate this topic as one topic unless you do not have a very good idea of special theory of relativity. Because when you do relativistic electrodynamics, and then you realize that electricity and magnetism are not at all different from each other. The same way space and time are not very different from each other, and I can think of them as one entity. I can think of electricity and magnetism as one entity, and I have to deal with what is called electromagnetic tensor. You study that when you study electromagnetic waves. So the point I was trying to highlight, that how different branches of physics, they're intertwined together. That you study spatial theory of relativity, and then you realize that this has applications in explaining why electricity and magnetism, how they can be written down together, and how you should not think of these two phenomena separately, but in fact just one phenomena. Okay. For UPSC, I'm very sure that you guys know the syllabus. The entire syllabus is divided into three main parts. The first part is about statics. So we are not talking about essentially moving magnets or moving charges. We are talking about stationary charges, and we are talking about stationary magnets. So we study what is called electrostatics and magnetostatics. So this does not involve dynamics. We do not have to go into the dynamics part of it. We do not want to see the time evolution of things. We are only interested in how due to charge and magnets, how the nearby space is affected, right? So hence the word electrostatics and magnetostatics. When we start this, we should always start with the very basic ideas which you have learned even in your class 11th and 12th. We should not try to jump, even for UPSC preparation, we should not try to jump directly into Laplace and Poisson equation. Of course, this will, because when you start with very basic, you will realize that this is a very obvious consequence of the fundamental laws which you learn even in class 11th and 12th about the ideas of electric field and electric potential. And then you connect that with vector calculus, and suddenly you have Laplace equation or Poisson equation. So that is the first part. Energy of a system of charges, multipole expansion of scalar potential, method of images and its application. This is a very profound idea in electrostatics, that how certain problems which prima facie will appear to be so complicated and so difficult, but can be answered with a very neat trick. And there is a reason why that trick functions. So this is method of images. This is something which you learn even in your class 11th and 12th classes. Potential and field due to a dipole, force and torque on a dipole in a external field. This is very easy. But rest of the thing, you do not study that in your class 11th and 12th. So dielectrics in detail, polarization, and more importantly, this part, and if you look at the past 3-4 year questions, you will realize that ये जो part है, this was being neglected by UPSC. इस पे कम questions थे, but अब पिछले 3 साल के 4 साल के question देखो, you will find that there are many questions on solutions to boundary value problems, conducting and dielectric spheres in uniform electric field. That's a separate topic. And then this last 2 line of this syllabus, which again was being neglected a lot by UPSC, but you'll now find that in last 3-4 years, every year, there is a question on magnetostatics. Only 2 words are given, 2 lines are given in the syllabus on magnetostatics: magnetic shell, uniformly magnetized sphere, ferromagnetic materials, hysteresis, energy loss. But this topic has become important for UPSC. And this requires deep conceptual analysis as well as little bit complicated mathematics. So for me, in the entire paper 1, if I have to think in terms of difficulty, then this is a section which is difficult. So in paper 1, the easiest part is optics. That is very easy. Optics is very easy, like straightforward, simple. Thermodynamics is very conceptually rich subject, but thermodynamics is also quite easy, at least for UPSC जो आपका syllabus है बहुत easy है. Classical mechanics can be very difficult, but your syllabus again is very easy. Classical mechanics syllabus of UPSC is very easy, so is relativity. The 2 little bit difficult part of the syllabus is this: electricity and magnetism and statistical physics. Statistical physics also can be very difficult, but your syllabus is not that difficult. But in electricity and magnetism, they do ask some difficult questions also, some tough questions also. So not only this is conceptually a very rich subject, but mathematically also it is not that straightforward as, let's say, what is your optics syllabus or your thermodynamics syllabus. Okay. We will look at some of the questions and you will realize what I am talking about. This is very familiar. All of this is simply a little bit extension of what you already have learned in your even class 11th and 12th. Forget about graduation. In class 11th and 12th, you have to study current electricity in great detail, and almost everything which is given here, except perhaps the last part here, quality factor and principle of transformer, everything else you study in class 11th and 12th also. It's just that it is a little bit extension of what you have studied. So you study Kirchhoff's law, Bayes-Art law, Ampere's law, Faraday's law, Lenz's law, inductance, AC circuits, LRC circuit, RL circuit, LC circuit, everything you study in class 11th and 12th also. So this is easy part of the syllabus. And this is again a difficult part of the syllabus: electromagnetic waves and black body radiation. So this is where now everything converges. And this is where many branches of physics converge. This is where optics converge with electrodynamics. This is where you realize that certain things cannot be explained with help of classical mechanics, and we have to jump into quantum mechanics. So this is where, this is a point which essentially the failures of classical physics, it forces you to look beyond classical physics, and it led to genesis of quantum mechanics. So studying this topic, and particularly studying the strength as well as limitations of this topic, is very important to appreciate that jump from paper 1 to paper 2, that why I need quantum mechanics in the very first case, right? So particularly when you go to black body radiation and you realize that classical laws of physics will not be able to explain this really well. So this is mathematically again complicated. In fact, it is even more complicated than the first topic, electrostatics and magnetostatics. And same here, conceptually, this is also a very rich topic. This is the only part of the entire syllabus where the, two places where the word tensor is properly given. So generally tensor analysis is not, you are not supposed to study that, but in electricity and magnetism, this tensor analysis is properly given. So this is again requires a detailed mathematical scrutiny if you want to become expert in that. Why you should do this topic really well? This topic you cannot afford at all thinking that ठीक है बहुत मुश्किल है इसको 8 में 5 ही तो करना है. Why you should not do that at all? उसका 2 कारण है. पहला तो कारण ये है that remember in compulsory question जो question number 5 होगा, there will be 3 questions from this section only. Out of 5 there will be 3 questions from electricity and magnetism. There is a high probability that 3 questions will be from electricity and magnetism first. So you are essentially going to skip those 30 marks question. Second, UPSC now in almost every other question also, so question number 6, 7 and 8, there will be at least one question which will be from electricity and magnetism, okay? And third, that once you know the topic, only then you can appreciate that should I attempt or should I not attempt this. So you should do all part of your syllabus thoroughly so that you are the best judge of that out of 8 questions, which 5 I need to attempt. If you do not do one part properly, then आपके पास फिर options नहीं है. अब आप forced हो कि हम यही कर सकते हैं, तो बाकी तो पढ़ा भी नहीं था. So that should never be a condition that where your syllabus is not complete and you simply like leave things to chance, that hopefully what you have studied will be part of those question number 6, 7 and 8 and you will be able to get all the answers. Only one book I recommend for this topic, Griffiths, one of the best books written on physics, not just on electrodynamics, but one of the best books written on physics. Books which go into detail of the rigor of physics rather than simply throwing you mathematical formulas are the best books. So whenever you are studying any book on physics, then always try to look for those books where lot of emphasis is given to physics and then on mathematics. It should not be that only maths is given and you are supposed to remember some formulas and proceed further. So out of so many physics books, this is the best, one of the best book, if not the best, one of the best book I have read, and this is why this is a highly recommended book for all the aspirants. What I have done in electricity and magnetism, I have divided this topic into 4 tutorials. Although I given the significance on magnetostatics in last few years, I could also divide this into 5 tutorials. So tutorial 1 includes that first topic, electrostatics and magnetostatics. Tutorial 2 includes that second topic, current electricity. Tutorial 3 is electromagnetic wave and tutorial 4 is black body radiation. That I have, because black body radiation requires a entirely separate discussion, so I have created a separate tutorial for this. Given the significance of magnetostatics, I will repeat this. I could create, in fact, I do think that I will make one more tutorial here, and there will be 5 tutorials in this topic. One tutorial for electrostatics and another tutorial for magnetostatics, okay? Let me show you, in fact, the tutorials I have before I jump into the questions. So this is last, I would say 11-year question or 11-year question. So from 2013 to 2024, you will find all of the questions of electrostatics and magnetostatics is given here. We do not have time to discuss all of this. So we are only going to discuss the questions asked in last 3 years. We'll start with this question. We'll start our discussion with this question. So 2022, 2023 and 2024. Similarly, this is the entire tutorial of current electricity, electromagnetic waves, and black body radiation. So without one more thing before I jump into the discussion, that I wanted to highlight the significance of this. Even though it is only 3-year data, but even with help of 3-year data, you can understand the relative significance of these topics. So clearly you can see that tutorial 1 is the most important part here. Most of the questions will be from electrostatics and magnetostatics. So every year 50 marks question you can expect from this topic. At least one or even 2 questions in the compulsory question will be from this only, electrostatics and magnetostatics. Tutorial 2, if you look at again the questions of 14, 15, 16, not so many questions, but now these days every year at least there is a 15 marker or 20 marker question from this topic of current electricity. Tutorial 3 has always been very important, even today this is important. So electromagnetic wave and black body radiation, this always has been very important topic. Okay, so let's start the discussion. Let's start with the first tutorial, the questions on electrostatics and magnetostatics. Look at the very first question. Consider 2 point charges, 2 particles of charge q each, separated by a distance d and traveling at non-relativistic velocity v. If the line joining the 2 charges is perpendicular to v, then write an expression for the magnetic forces between the 2 particles and illustrate the direction of the force on each particle. Okay, how are we going to do that? We should always try to make a diagram. I do have the entire scanned copy, because if I start solving it, this will take like a lot of time. I do not want that to happen. I will always make a diagram first. Wherever it is possible, I will always make a diagram first. This is my diagram. I have 2 charged particles maintained separated by a distance d, and the distance, this vector, is perpendicular to their motion itself, right? The velocity itself. Okay. So I have assumed these 2 charged particles in xy plane, and z plane is coming out of the paper. Ideally I do not do that. Ideally I make this as my xy plane and vertical line is z axis. Okay, so but nonetheless इस क्वेश्चन को और डिफिकल्ट हम देखो कैसे बना सकते थे. ये तो फिर भी बहुत इजी क्वेश्चन है. हमने क्या कर रखा है? वी मेड सर्टेन assumptions. Assumptions, whatever assumptions you make, you write it down. The charge 1 is moving along x-axis, charge 2 is at distance d along y-axis, but moving with the same speed. So it is distance d, but moving along again the x-axis. So they are maintaining the same constant velocity. Okay, and the question is saying that what is the magnetic force they are going to experience. We know that any moving charge, magnetic force at distance r is mu naught by 4 pi q v cross r by r square. Very simple, we know that. If I take r here, proper r vector, then I will write r cube here. So ये बहुत clear, ये याद रखना ज़रूरी है. This is r unit vector. So I have to now calculate that how much magnetic field one of the charge is going to produce at that distance d, and then I simply have to calculate the force based on that. So I know the magnetic field, so I know V. V is Vex, R is Ey, right? Vector R is Ey. I am trying to calculate magnetic field due to this charge on this charge, right? So this R vector here is towards y-axis. So hence that unit vector R is nothing but Ey. And then the calculation is very easy. B1 is mu naught by 4 pi QV Ex cross Ey by d square, mu naught by 4 pi QV Ez by d square. So that immediately tells you that what will be the direction of magnetic field due to charged particle, and the direction will be towards z axis. So it will be coming out of the paper. If I have to write it down, I will write that with that small dot. And if I know the magnetic field, then I know the force, and force is qv cross b. अब force जो है magnetic force on particle 2 due to the magnetic field of particle 1, that is qv cross b. This is qvex. I have just calculated b1, mu naught qv 4 pi d square ez, and here I am getting this magnetic force is mu naught q square v square 4 pi d square, but more importantly I am getting this minus ey, which is telling me that it is an attractive force. So minus ey का जो direction है, it is towards this particle. So it is a attractive force. Now this is very interesting because for same charges, electrostatic force will be a repulsive force, but in this case the magnetic force is a attractive force. Can you relate this to something which you already have studied? Like class 11th 12th में आपने एक पढ़ा होगा simple सी चीज़, that two wires, electricity in the same direction, and they attract each other. पढ़ा है हमने. But think about it, if charged particles are moving, then it is nothing, I can think of this as a electric current. So we already can understand, we have learned this, that how electric currents attract each other in the same direction in two wires. It's very similar to that. So force on 2 is towards 1, and I do not have to calculate the same thing. I can simply apply Newton's third law. Remember, there is nothing else, equal and opposite reaction. So force on 1 due to 2 will be mu naught q square v square 4 pi d square, but the direction is going to be now opposite. So minus ey versus ey, and force on 1 is towards 2, and I'm simply going to write that this is an attractive force. ये लिखने पे हमको जो 0.5 है मार्क्स जो मैं बता रहा था, ये लिखना पड़ेगा हमको. If I only complete my answer by deriving it and leave it there, versus if I elaborate it, that an attractive force, even though both are like charges, and this is purely due to magnetic field, right? And I have mentioned this, that this is very similar to current in the parallel wire. And then finally I have given the diagram also, that इसके कारण जो magnetic field है, that is coming out of the paper. इसके कारण जो magnetic field होगा, that will be going inside the paper, and the force however in both the cases will be attractive. So Q coming towards another Q. If UPSC wanted to make this a more difficult question, and the more difficult question will be that introduce now that do a time evolution of these two charges based on both electrical and magnetic forces. So now you have to calculate that at a particular juncture, what is the electrical force which will be repulsive in nature, and what will be the magnetic force. And one thing which you can immediately appreciate here is that the electrical force will be repulsive, but also will be in the, so for magnetic force is in this direction, minus y direction, the electrical repulsion force on this charge will be in the positive y direction. So the net effect of that, still I can do a simple subtraction, right? E minus F1 minus F2. And based on that, how time evolution of these two charged particles can happen, that can be a very good question, more difficult question, but that can be a question which can be asked. It can be also shown that for non-relativistic speed, the magnitude of magnetic force will be much, much less compared to the magnitude of electrical force. So even though there is an attractive force, that repulsive electrical force will overpower that attractive force in the longer run, right? So this is one of the simplest application you can expect to be asked by UPSC. But immediately look at the second question. Second question is a boundary value problem. We just talked about boundary conditions. That a current sheet having current density is given. Current density is in towards y-axis. ये जो AY है, remember ये engineering textbook में unit vector को AX, AY, AZ में हम बहुत बार represent करते हैं. So just remember, this is nothing but a unit vector towards y-axis. And this tells you that UPSC बहुत बार engineering textbook से question बना रही है. Because if you read any proper physics textbook, then they will either use IJK, or they will use X cap, Y cap, Z cap, or they will use EX cap, EY cap, or EZ cap. They will not use AY. But in many engineering texts, you will find this as a very famous notation. Current sheet is given. The interface is between the region Z is less than 0. Mu is different in region 1 and region 2. And given that in the second region, H2 is given, you have to calculate H1 and B1. So this is a very good question on boundary value problem. But before this question, before I discuss this question, let me discuss a question asked by UPSC last year. A 15 marker question. Now this is a more standard question. So standard derivation हम पढ़ते हैं. That obtain the general boundary conditions for the field E, B, D, H at a boundary between two different media carrying charge density sigma or a current density K. So for sigma, I will have to calculate E and D boundary condition. For K, I have to calculate boundary condition of B and H. So let me first show you the solution of this, and then how I am going to apply this solution to the earlier question. I am going to discuss that. कैसे निकालते हैं boundary condition? If you guys remember, how do we calculate boundary condition? I have a Gaussian surface. I want to calculate that the E perpendicular here and E perpendicular here, above and below, versus again in the same Gaussian surface, E parallel here. In fact, let me write this E parallel here. E parallel here versus E parallel here. How it changes when it crosses a particular boundary. And assume that this has charge density sigma. Okay. So what do we do in such type of questions? We use Gauss's law, and we use essentially a small Gaussian surface, that I assume a small Gaussian surface. I take that Gaussian surface to be of area A, and I use two rules. First rule will be that E dot dA will be Q by epsilon naught, Gauss's law, and the second rule I am going to use. For that, I will use another small rectangular thin parallel to this, or in fact let me make a very thin strip, and I use E dot dl is equal to, what will be E dot dl? Line integral of electric field. What will be the answer? It's a conservative field. Electric field is conservative field. If I'm taking a line integral, it will be 0, right? So I use this for this Gaussian surface. I look at the, if I assume that is Gaussian surface का thickness बहुत ही कम है, negligible है, तो जो flux contribution from this side way I can neglect that. So the only flux contribution is happening on the surface. So only flux contribution is because of E perpendicular below and E perpendicular above. And then I simply put it and I find a boundary condition that what will be E perpendicular. For this small line integral, again I take this length to be very, very small. And I apply E dot dl, and then I see that how this parallel electric field is going to change when electric field crosses this particular conducting medium. I do the same thing for B and H, but rather than using Gauss's law, now we will be using Ampere's law. And I use Ampere's law, and I get the boundary condition for B and H, right? So let me show you all of that. This is exactly what I have shown here, that I take a Gaussian surface and I want to calculate that electric field के जो components हैं, एक जो perpendicular component है, so perpendicular का मतलब यहाँ पे क्या है, perpendicular to the surface. That if I take a unit vector which is perpendicular to the surface, then what happens to the electric field perpendicular to that, and what happens to the electric field parallel to that. And for that, I take that Gaussian surface, I write it all of that. Whatever we are making in crisp and concise form, I will write that. We choose a thin Gaussian surface of area A and thickness T. And at the end, I will assume that this T is essentially tending to 0, so that I can neglect that flux from sideways. So if T is 0, so E dot dA, Q by epsilon naught, Q is nothing but sigma times A, sigma is surface charge density. I can take E out of it. So E perpendicular above minus E perpendicular below is nothing but sigma by epsilon naught. For a very small thin surface, I assumed that throughout this, for a very small, throughout this surface, electric field is essentially not changing in direction, and because of that, I took E out of the integral. And integral dA is nothing but A khatam ho gaya, so I find a very nice relationship, which is that the perpendicular component of electric field that has a discontinuity. This is not continuous, it changes by sigma by epsilon naught. And if I choose that length, a line integral, and I use this property that E dot dl is 0, then for parallel component, E parallel above, E parallel below into L, that is 0. So E parallel above, E parallel below, that is going to be the same. So now we have my boundary, we have our boundary condition that parallel conditions, parallel components of electric field, they do not change, but there is a discontinuity for perpendicular component. Okay, and if you want to write this together, then there is a very beautiful relationship you can write, that in vector form, E above, E below, it's sigma by epsilon naught. N, this N is the unit vector perpendicular to the surface, right? So if I take parallel component, it is going to be 0. Iska koi bhi component parallel nahi hoga, this is going to be 0. If I take perpendicular component, then this will be 1, sigma by epsilon naught. So I have combined that into one particular equation. So this is my general boundary condition for electric field. And for electric displacement vector D, remember for electric displacement vector, why do we introduce this? We introduce this in case of dielectrics, and for dielectrics, a more useful vector is this D, which is epsilon naught E plus P. If you guys remember that, D is epsilon naught E plus P, where P represents polarization, right? And when you do Gauss's law for such type of setup, then you find the Gauss's law changes to D dot dA and free charge. So why we introduce electric displacement vector? Because we do not want to worry about the bound charges which has occurred due to electric field. We are only interested in the free charges. So Gauss's law changes to this. There is no epsilon naught here. You can see this. यहाँ पे कोई epsilon naught नहीं है. So accordingly, same thing. I take a Gaussian surface for perpendicular component. There is again a discontinuity. The only thing is that there is no epsilon naught here. So D perpendicular above minus below, there is a sigma f. And for parallel, however, D is epsilon naught E plus P. So del cross D is epsilon naught del cross E del cross P, which means that while del cross E is 0, remember electric field जो है उसका जो पूरा curl है वो 0 होगा. But यहाँ पे ज़रूरी नहीं है कि जो मेरा polarization vector है उसका भी कर्ल 0 हो. So यहाँ पे ज़रूरी नहीं है that this parallel component is continuous similar to electric field. So I will write, this is my general relationship, and if del cross P is not 0, then both normal and tangential component are discontinuous. But if I assume that I have an isotropic medium, polarization is everywhere uniform, then I can assume, or if I assume that polarization का जो curl है वो 0 है, then I can say that even parallel component of electric displacement is same. But that will not be generally true. So this is my boundary condition for electric displacement vector D. I do the same thing for magnetic field, but for magnetic field, these things will now become exactly opposite. For magnetic field, B dot dA is 0. There is no magnetic monopole. So B dot dA is going to be 0. And B dot dL is going to be, using Ampere's law, mu naught I. I will come to that in a moment. So B dot dA is 0, which means that B perpendicular above and B perpendicular below is going to be the same. While in case of electric field, there was a discontinuity, in magnetic field, there is a continuity in the perpendicular component. But for parallel component, I am now going to use Ampere's law. So while in case of electric field, E dot dl was 0, for magnetic field it is mu naught I. Now I can be written as simply K times L, and I remove L, and this is my discontinuity for B. So parallel component of magnetic field is discontinuous. And if I want to write this together again, I can write it like this, that B above minus B below is mu naught K cross N. If N is perpendicular, then accordingly how this is going to change versus if it is parallel component. For magnetized material, जैसे electric displacement फिर भी उतना useful vector नहीं है. जब भी आप कोई भी electrostatics जब आप करोगे, hardly there will be a case where you will be dealing with D. Most of the time you are going to deal with E. But in case of magnetic field, that's not the case. In case of magnetic field, H is a very useful quantity. That when there is a magnetization represented by capital M here, then this H becomes a very useful quantity. In fact, for many things, for many cases, H becomes even more useful than B. And as a result, you will often find that many authors call H as magnetic field or H as magnetic intensity. But B is a more fundamental quantity. There should be no doubt about it, that B is a more fundamental quantity, and hence we should use this word magnetic field or intensity for B. But I'm just telling you that you'll find many textbooks where we use the word magnetic field or intensity for capital H and not for capital B. So H is a useful quantity. Del cross H is JF. Same way electric displacement के case में I found Q free. In case of if I use H, I find free current versus bound current. So again, I do not want to deal with bound currents. I am only interested in free currents. And as a result, but if I take the dot product, then del dot H, while del dot B was 0, del dot H is going to be minus del dot M. And accordingly, your boundary condition will be this, that even perpendicular component may or may not be continuous. So if magnetization is not same, then H is not going to be continuous. But if there is a magnetization, then H is going to be discontinuous. But for parallel component, it always will be discontinuous if there is a charge density, which will be Kf cross N. तो ये हमारा complete boundary condition है. This is a very standard question. Syllabus में दे रखा है आपके boundary condition, and UPSC ने 15 marker का ये पूछा था on the question on boundary condition. Now I will, do you all of you have notebook? Would you try to solve this question now? I will show you the boundary condition just in case if you do not forget it. But now can you solve this question? Look at this question. Make a proper diagram. That what this entire diagram is, that a current sheet K is given 9 AY, so it is towards Y axis, is located at Z is equal to 0. The interface is between the region 1 Z less than 0 and region 2 Z greater than 0, and mu is different. Given that H2 is given, find H1 and B1. So let me in fact help you more, and I'm very sure that you guys can do this all by itself, but let me further help you, that this is my condition. So this is my XY plane, and you can think of this XY plane, this is Z is equal to 0. तो मेरा जो रीजन 1 है वो ये है, जो रीजन 2 है वो ये है Z greater than 0. K is given along y-axis. K is mentioned in the question. K is given along y-axis. This is mu2. This is mu1. mu2 का value क्या है? mu2 is 3 and mu1 is 4. H2 is given. H2 is given as 14.5 AX plus 8 AZ. And you have to calculate what is H1 and what is B1. ये क्वेश्चन दे रखा है. Make this diagram just in case you have any doubt about the boundary condition. The boundary condition is B perpendicular, this remains same for both above and below. So the perpendicular component hai, that remains the same. And if I have to talk about H here, then H parallel above minus H parallel below, and boundary condition is K cross N. Use these two boundary conditions and try to solve this question. H2 is given, you have to calculate H1 and B1. N क्या होगा यहाँ पे? जो unit vector N है क्या होगा? No, direction क्या होगा? For this reason, what is the perpendicular? ये XY plane है. XY plane के लिए unit vector perpendicular क्या होगा? Z axis. So N is nothing but Z cap. K is given as along Y axis. K is also given, by the way. Current density, that is also given. And that is, what is the value of current density? 9 AY. And remember, B is mu H. याद रखना है हमको. B is mu times H. you have to be very careful when you are applying boundary condition. Look at H2. H2 has two components. One is along x-axis, another is along z-axis. So one which is along x-axis, I can think of this as a parallel component to this surface. And one which is along z-axis, I can think of that as a perpendicular component along with the surface. I just told you that if there is magnetization, then there is no guarantee that H perpendicular will be the same. But that is why I gave you B perpendicular here. There is a reason I gave you a hint there that don't calculate H. I do not know if H is continuous or not, but I know that my B is going to be continuous. Now what is B? B is nothing but, so I can say that mu2 Hz or H2z will be same as mu1 H1z. Can I say that? That H2 का जो z component है, जो कि यहाँ पे 8 होगा, multiplied by mu2 should be same as mu1 into H1z. And H1z अभी हमको पता नहीं है, but rest everything is given, so I can do this calculation. Mu2 is given to me. Mu2 is 3. Hz is 8. This is also given 4. And H1z मुझे अभी पता नहीं है, so I have to calculate that. I immediately know that H1z is equal to 6. So it is along z-axis. Okay. So look, there is a small trick I have done here. I did not use the boundary condition of H perpendicular because I have no information about the magnetization here. So hence I use the boundary condition for B perpendicular. But for here, the parallel, I have all the information necessary. Now look at the parallel component. Parallel component क्या है यहाँ पे? 14.5. So if everything is given here, H parallel above, this is given. I have to calculate H parallel below. So I can simply take this K cross N and that will be H parallel below. So I know all of this. What is H parallel above? H parallel above is 14.5 minus K is also given 9 AY cross AZ. AY cross AZ. And the best part is that this is also 14.8 AX. So AY cross AZ is AX and this is my H parallel below. So what is my H parallel below? H parallel below is, this is AX, AY cross AZ is AX, 14.5 minus 9, this is 5.5 AX. 5.5 ही होगा ना? हाँ, 5.5 AX. So now I have my complete answer, that जो मेरा H1 है, that is equal to 5.5 AX plus, we had calculated this 6 times A Z. And if I know H1, then I already know B1. B1 क्या होगा? mu1 times H1. mu1 is given as 4. Calculate that. This is 22 times AX plus 24 times AZ. Okay. The point is that जो हमने स्टैंडर्ड डेरिवेशन अभी जस्ट किया, स्टैंडर्ड डेरिवेशन का जो फाइनल फॉर्मूला है एंड वो दिमाग में रहना चाहिए. एंड द बेस्ट पार्ट ये है कि हमको रटने की ज़रूरत नहीं है. जस्ट रिमेंबर दैट वो फॉर्मूला डिराइव करने के लिए आई यूज्ड गॉसेस लॉ, आई यूज्ड एम्पियर्स लॉ. एंड इफ यू हैव गॉसेस लॉ एंड एम्पियर्स लॉ इन योर माइंड, then you can immediately think of the boundary condition, that how the perpendicular component will change and how the parallel component will change. This is what I have done here. You can see this. I will try to make very clear diagram. This is my region 1. This is my region 2. All the information which is given in the question, I will write it down so that I can utilize it. And we know that normal component of B is continuous. I have calculated H from that. And we know the tangential component has a discontinuity. Based on that, I calculated the tangential component. and I have my total H1 parallel, H1 perpendicular, and I have calculated that, and I also have calculated B1 based on that. Okay, one page complete. How much marks was of this question? ये 15 नंबर का क्वेश्चन है, एक पेज में कंप्लीट हो गया. But I need to know the proper boundary conditions. It will take about 3 to 4 minutes, and you have solved this question. Next question. ऐसे क्वेश्चन याद रखना है, यहाँ पे कैलकुलेटर पे आपका जो कमांड है वो अमेजिंग होना चाहिए. That you should try to use calculator daily in the class. When you are taking classes, when you are solving question, try to use calculator. क्वेश्चन इतना आसान है, बहुत easy question है. Find the energy stored in a system of 4 charges Q1, Q2, Q3, Q4, 1, 2, 3, 4 nanocoulomb. Placed at the Cartesian coordinates. Coordinates are given 1, 1, 2, 1, 1, 4, 2, 2 respectively. Assume free space. What is the energy? अब देखो क्वेश्चन तो बहुत ही आसान है. One is at 1, 1, another is at 1, 4, another is at 2, 1, another is at some 2, 2. ऐसा कुछ configuration है. Right? ये Q1 है. Q1 is 1 nanocoulomb. Q2 is at 2, 1. This is 2 nanocoulomb. Q3 as 1, 4. This is 3 nanocoulomb, and this is Q4 at 2, 2. And I have to calculate the total energy stored of this system. Direct formula लगा सकते थे, but ऐसे भी सोच लो. When nothing was there, I brought Q1. I have to do no work, no energy due to bringing Q1. When Q1 was there, I had to brought Q2. So my energy Q1 Q2 by 4 pi epsilon naught R. ये R हम देख लेंगे. Both Q1 and Q2 are there. So when I bring Q3, then it will be Q3 Q1 Q3 Q2 by 4 pi epsilon naught R. And when all three are given, then I brought Q4. So Q1 Q4, Q2 Q4, Q3 Q4. अब यहाँ पे एक्स्ट्रा मार्क्स लाने के लिए हमको क्या लिखना पड़ेगा? एक सिंपल सा हमको वर्ड लिखना पड़ेगा, that जो potential energy है that follows linear principle and it follows superposition. That when I am bringing this Q4 charge, then the impact of Q1 on Q4, I can neglect the impact of Q2 and Q3. So while calculating the total energy stored, I do not have to worry about that what is Q2 and Q3 doing while calculating about Q1. So I can think of this all as independently, and I can simply do a linear sum in the end, and my answer will be complete. Right? So ये बहुत ही powerful idea है, and it's frankly not exactly accurate. Turns out that when you study quantum electrodynamics, and you do find that it is not exactly a linear sum. There is a small thing you have to take care of. But for day-to-day calculation, we do not have to worry about this at all. तो question तो बहुत आसान है, but देखो ये 1, 1 है, ये 2, 1 है, ये 1, 4 है, और ये 2, 2 है. तो ये जो distance वगैरह calculate करना है, ये झट-झट होना चाहिए. तो या तो आप मन में करो या कैलकुलेटर से करो, जो भी करो, ये बिल्कुल जल्दी से ये डिस्टेंस क्या होगा, ये डिस्टेंस क्या होगा, ये सारे एकदम जल्दी से होने चाहिए. एंड इस कैलकुलेशन में आपका टाइम नहीं लगना चाहिए. तो ऐसे क्वेश्चन में बस प्रॉब्लम ये होता है दैट प्राइमा फेसी दिख रहा है आपको, दिस इज अ वेरी इजी क्वेश्चन, बट यू स्टार्ट स्पेंडिंग लॉट ऑफ टाइम, यू गॉट स्टक इनटू कैलकुलेशन. दैट मस्ट नेवर हैपन. दैट इज द वर्स्ट थिंग व्हिच यू कैन डू इन द एग्जामिनेशन. सो एनीवेज, लेट मी शो यू. I can directly use the formula 1 by 4 by epsilon naught q by qj r ij whenever I have such assembly, j less than I. This is the total energy. So u12 I will write 4 by epsilon naught q1 q2 by r12. Similarly I will write u13, u14, u23, u24, u34, and I'll have to calculate all of this distance r1 minus r2. So x1 minus x2 square, y1 minus y2 square. I have to do this calculation, and simply I have to do a linear sum, and I will mention this. The total potential energy of system of a point charge, its sum of potential energy of each unique pair independent of other charges. I will mention that, and this is called superposition principle. So the moment I do that, I get that 0.5 marks extra, rather than directly jumping into writing the answer itself. Okay. Next question, very, very beautiful question. A neutral atom consists of point nucleus plus Q surrounded by uniformly charged spherical cloud minus Q of radius r. Show that when such an atom is placed in a weak external electric field, the atomic polarizability of the atom is proportional to the volume of the sphere. Can you think of ये question का जो description है, if you have studied evolution of atomic structure, history of evolution of atomic structure, that what people thought about atom. So they thought that you have a cloud of electron, right, dispersed, and then you have at the center you have a positive charge. And later, of course, we got to know that we should think of this as a nucleus and the overall electron cloud, not a continuous distribution of electron cloud, but discrete distribution based on orbitals, which you study in quantum mechanics. तो ये हमारा क्वेश्चन क्या है, एंड आई वांट योर इनपुट कि आप इसको कैसे सॉल्व करोगे. ये बहुत इजी क्वेश्चन है, 15 मार्क्स का है. अभी 15 मार्क्स आपको तब मिलेंगे when you properly present your arguments. If you do not give your arguments, directly jump into mathematical calculation, you will not get marks. So let me first make a diagram that what this picture, what this question is trying to ask. Question is saying that I have a positive charge plus Q, and then I have a cloud of negative charge, the total cloud of negative charge, that is minus Q. This was our primitive model of atom. People thought that this is what an atom is, a continuous distribution of electron everywhere. This is a primitive model of atom. Now the question is saying that we place this into a weak electrical field. Let's assume that this electric field is towards x-axis. Let's assume that. Okay. What this will look like, what my next arrangement will look like, you tell me. That due to this entire thing being placed into an electric field like this, what it will lead to. I can easily think that there is a force on this charge due to this external magnetic field. As a result, this positive charge is going to be displaced a little bit towards this direction. Let's say that this displacement happened by distance d, that my charge is now plus Q. And as a result, I also find that I have a negative charge. So there is a shift of negative charge towards this side, and there is a shift of positive charge towards the right. If it is a weak external field, I can assume that even though my negative charge cloud has been disturbed, I can assume that for very small displacement, the spherical volume has been maintained. That जो पूरा cloud of negative particle है, that still is in a spherical structure. ये assumption है, लिखना पड़ेगा हमको. This is my assumption. In reality, it is not going to happen. Think about it. In reality, it may take some sort of irregular shape, but I am assuming that my spherical shape has been maintained. As a result, because there is a displacement of positive and negative charges, and I am saying that this displacement, let's represent that with d, this displacement will keep on happening till the point of time that due to this displacement, there is now an internal electric field, let's call this EE. तो डिस्प्लेसमेंट रुकेगा कब? व्हेन EE इज इक्वल टू कैपिटल E. ठीक है. अब हमको क्या कैलकुलेट करना है? हमको ये EE कैलकुलेट करना है, जो इंटरनल इलेक्ट्रिक फील्ड है. वी हैव टू कैलकुलेट दैट. ये हम कैसे करेंगे? हाउ विल वी डू दैट? दिस इंटरनल इलेक्ट्रिक फील्ड, आई विल यूज गॉसेस लॉ, दैट आई हैव टू कैलकुलेट दैट ड्यू टू दिस नेगेटिव चार्ज क्लाउड what is the electric field at this particular distance. यही करना है ना हमको कैलकुलेट. तो इस पूरे वॉल्यूम में चार्ज मेरा कितना है? 4 pi by 3. I have assumed a displacement by d, so 4 pi by 3 d cube is the volume, multiplied by rho. Rho is my volume charge density, which I can write as q by 4 pi by 3 r cube. This is my charge divided by epsilon naught, and that should be equal to E dot dA, Gauss's law. I am applying Gauss's law. Because it is a uniform charge distribution and at a particular radial distance, it should be same everywhere. So I can take that E out of the integral, and this is nothing but E into 4 pi r square, right? अब ये देखो, पहले तो 4 pi by 3 से हम 4 pi by 3 हम इसको हटा देते हैं. So this is q dq by rq. ये क्या है? q dq by epsilon naught rq is equal to E into 4 pi r square. ठीक है? So यहाँ से मेरा E निकल गया. And in fact, let's call this internal electric field. I was calling this internal electric field. So E is equal to Q by 4 pi epsilon naught this was capital R. Let's call this. थोड़ा सा यहाँ पे गलती कर दे. This is 4 pi d square. Please make corrections whenever I am making a mistake. So this was this small sphere. So this is not r square but d square, and this is r is the total radius, right? So this is also d square. So this becomes 4 pi epsilon naught r cube. All of this is constant. dq by d square, this becomes d. ये हो गया ना हमारा. अब क्वेश्चन ये बोल रहा है that you have to show that polarizability is proportional to the volume of the sphere. So इसको मैं लिख सकता हूँ ऐसे. So polarizability QD is equal to EE into 4 pi by 3 r cube into 3 epsilon naught. ये लिख सकता हूँ मैं ऐसे इसको. This 4 pi by 3q is nothing but volume, my polarizability, and it becomes proportional to volume. हो गया? So this is nothing but 3 epsilon naught V EE. This is my total dipole moment, and polarizability becomes proportional to volume of the sphere, and my calculation is done. But if I do not explain my argumentation properly, so let me show you how I will write the complete answer. Because remember, it is a 15 marker question. I will make my diagram. I clearly will label the figures that I am trying to show this different figure. My figure 1 is the normal condition plus q and a uniform distribution of minus q. Due to external electric field, there is a small displacement d, that is my figure 2. I clearly mention, I also have mentioned that this is actually a primitive model of an atom, positive charge and a uniform negative charge. And I mentioned that in the presence of external field E, nucleus will shift slightly to the right and electron cloud to the left. And if I assume this displacement to be very small, spherical shape is retained. This is an assumption. Without this assumption, I cannot apply Gauss's law. Remember, Gauss's law is only and only useful if I have symmetry. If I cannot take E out of that integral, then Gauss's law is correct but not at all useful for me. So Gauss's law becomes only useful when there is a symmetry. So at this equilibrium, when nucleus is displaced by some distance, E should be equal to EE. ये मेरा proper argumentation है. And इसके लिए अब हम Gauss's law calculate करेंगे that E dot ds should be q by epsilon naught, qd by aq. I put all of that. हमारा E आ गया पहले तो 1 by 4 pi epsilon naught qd by aq, and that should be equal to external field which we have applied. P is equal to qd, 4 pi epsilon naught aq, atomic polarizability is alpha, 4 pi epsilon naught aq, P by E. This is 3 epsilon naught V. Atomic polarizability is proportional to volume of the sphere. That is what I had to prove, right? So the point is that 15 marker question, if I directly jump into this without giving proper argumentation, I will not get a lot of marks. So even though it does not involve a lot of mathematics, but it does involve that physical explanation, and I should do that to get the complete marks. ये जो दोनों क्वेश्चन है, ये दोनों क्वेश्चन बहुत ही मुश्किल है. Both of these questions were asked by UPSC for the first time, and that tells you that UPSC sometimes it increases the scope of what you have studied. कि अगर आपने खाली बेसिक पढ़ा है, जैसे पहला क्वेश्चन देखो, a spherical shell of radius r carrying a uniform surface charge sigma, it's set spinning at angular velocity omega about its axis. Find the vector potential it produces at r. Vector potential का definition पूछा है past में. Vector potential calculation for such a structure, ये पहली बार UPSC ने पूछा है. Now here I should tell you a few things here. UPSC अगर एक क्वेश्चन पहली बार पूछती है तो फिर उसके बाद पूछते रहती है उसको हर 2-3 साल पे. They keep on repeating. So I will prepare this well. This was I think asked in 2022, and I will prepare this really well. So while this question is very simple, again same year, this question is difficult. It's not an easy question. Let me show you the entire arrangement. ये मेरा arrangement है. My arrangement is that I have a spherical shell. It is a shell, not a volume. It is a spherical shell which is spinning. I do not know on which axis it is spinning. तो अब यहाँ पे हम दो चीजें कर सकते थे. हमको निकालना क्या है? हमको निकालना है that at some distance r, I have to calculate the vector potential. Okay. Now two things can be done. एक तो आप ये assume कर लो कि जो मेरा spin axis है वो z axis के along है. Like spherical coordinate system में things become easy if I assume something along z axis. Or you can assume that omega is random at some random axis, but the r which I am trying to calculate is on the z axis itself. I can do the calculation in both ways, and both ways will be fine. But if I do this in the second way, that I assume r is along the z axis itself, then it will become very clear that your calculation will be little bit easier compared to in the first case. तो ऐसे cases में हमेशा हमारा एक ही तरीका होता है. Because it is a shell, I do not have to worry about the volume part. I only have to worry about the surface part. So I take a dA at r. What will be dA in spherical coordinate system? Remember, r is capital, r is fixed. What is going to vary? At one I will vary theta, another I will vary phi. So what will be my dA? ये imagination होना बहुत ज़रूरी है. If you cannot imagine how things are changing in spherical coordinate system, then अगर आप directly खाली maths रटने की कोशिश करोगे कोई फ़ायदा नहीं है, right? So आप ऐसे इसको assume करो. ये मेरा xy plane है and ये मेरा z axis है, ठीक है? R तो vary कर नहीं सकते. It is a shell. R मेरा fixed है, capital R मेरा fixed है. So I can vary, if I want to calculate dA, I can vary that theta. Now remember, my theta can be this also, this also, this also. So let's say this is my r. So ये मेरा theta है. So I make a small d theta here and I create this particular distance. अब ये distance क्या होगा? So this is d theta. So it will be this particular length into d theta. And you immediately know that this length is nothing but r sine theta. If this is r, then this length is nothing but r sine theta. So this length is r sine theta d phi. And if I have to vary phi, then what do? I take this phi and I take phi plus d phi. तो ये जो मेरा length हो जाएगा क्या हो जाएगा? This is going to be rho d phi, right? So इससे हमारा dA निकल के आ गया. dA is going to be r square sine theta d theta d phi. So I will remember this. ये सारी चीजें में बहुत clear होनी चाहिए. That in spherical coordinate system, in cylindrical coordinate system, Cartesian is very simple. My real element is dx dy or dy dz or dx dz. My volume element is dx dy dz. But in cylindrical coordinate system, what it will be? In spherical coordinate system, what it will be? Without this particular topic, electricity and magnetism, you cannot do well. So electricity and magnetism is all about dealing with spherical coordinate system. Makes sense also. Electric field is a central field. So if it is a central field, I should deal things with spherical coordinate system. Okay. So I choose a small aerial element and I'm going to calculate the vector potential due to this aerial element at a particular point, and I have assumed that this point is on the z-axis, and then I am going to integrate throughout the sphere. For integration, how much theta कितना vary करता है spherical coordinate system में? From 0 to pi. Phi जो मेरा xy axis है, ये जो xy plane है, if I have chosen this as my positive xy plane, then to cover entire xy plane, I have to cover 5, 0 to 2 pi. But theta जो है, I am measuring that from z axis, right? So this z axis कहीं पे भी measure करूँ, इधर है, it's like a cone. If I take a theta, then it is like a cone. So theta varies from 0 to pi. 0 to pi by 2, essentially this covers northern hemisphere, and pi by 2 to pi, that covers southern hemisphere. So theta varies from 0 to pi. So I have to now, so that is what I have done. I have mentioned everything. Let r be located on z axis with angular velocity tilted at angle psi. I do not know what is there is a random orientation of angular velocity. I cannot assume that. So I have assumed that with z axis it is tilted with some angle psi, the angular velocity. We choose x-axis in a way that omega lies in xz plane. That we can do. I can, जो मेरा xy plane है, इसको मैं rotate तो कर ही सकता हूँ. जैसे मान लो ये मेरा xy plane है, ये मेरा z axis है. This is my xy plane. So without changing my z axis, I can always move my xy plane and things will be fine. So I can choose my xy plane in a way that omega is in xy plane. The reason I have done it, again my mathematics become simpler. So I have chosen my xy plane in a way, I will repeat this, xz plane in a way that omega is in only and only xz plane. I have mentioned that in a way that omega lies in the xz plane. Okay. So for the aerial element, we know the formula that for an aerial element, current density K, the vector potential is mu naught by 4 pi K r dot. I have given this r here. Why? This should be clear. This is dA, but from this point, this distance is this vector, not this vector. I want to calculate the vector potential at r vector with respect to center. But due to an aerial element here, I cannot use this r. I will have to use this r. The only thing is that this r and this r, they have a very nice relationship, and that relationship comes from that theta. Using that cosine law of triangle, I can make a simple adjustment. So K is sigma V, sigma is surface charge density, we know that. R will be r square plus r square minus 2rr cos theta dash, cosine law. And dA dash, as I was saying earlier, dA dash is going to be r square sin theta dash, d theta dash, d phi dash. This is my aerial element. V for a spinning angular spherical shell is nothing but omega cross r dash. So Ex, Ey, Ez, I assumed omega in a way that it is in xz plane. So I find omega sin psi, no y component, and omega sin z. And r dash, spherical coordinate system में r sin theta dash cos phi dash, that is the x component. This is the y component, r sin theta dash, r sin phi dash, and z component is simply r cos theta dash. So this is going to be my V. Do this, and this is your total cross product. And now use this. For total potential, I'll have to integrate that AR mu naught by 4 pi KR by R dA dash. अब यहाँ पे दो इंटीग्रल है. रिमेंबर यहाँ पे दो चीजें वैरी कर रही हैं. मेरा थीटा डैश वैरी कर रहा है और मेरा फाई डैश वैरी कर रहा है. बट फाई डैश कहाँ से कहाँ तक वैरी कर रहा है? 0 to 2 pi तक. एंड यहाँ पे सारे जो कंपोनेंट्स हैं वो या तो साइन फाई डैश है या कॉस फाई डैश है. और अगर sin phi dash और cos phi dash का अगर आप इंटीग्रल लो from 0 to 2 pi, what do you get? You get 0. So even though when I started it looked so scary that I have to integrate all of these components separately. But the moment I realize that wherever I have sin phi dash and cos phi dash, I can directly write that as a 0. So I only have to worry about the component where there is no phi dash. Which component is that? Is this? I have only one component, sin psi cos theta dash Ey. So this I have to integrate. So my total potential, so any terms with phi dash will contribute nothing. ये कुछ भी contribution नहीं होगा. So my AR theta dash 0 to pi, phi dash 0 to 2 pi, minus sigma sin psi cos theta dash r square sin theta dash d theta dash d phi dash, and r square plus r square minus 2rr cos theta dash. Now this is not a again very simple integration. ये जो है dA है, remember this is dA, okay? And put all of that, you have this as a constant, you take this out, mu naught capital RQ sigma omega sin psi by 2, and you integrate from 0 to pi cos theta dash sin theta dash d theta dash. By the way, what happened to that 2 pi? You can easily see that when I integrate d phi dash from 0 to 2 pi, that will remain. So there is a d phi dash, and d phi dash from 0 to 2 pi will be simply 2 pi. And in denominator I have 4 pi. So that has become 2 here, okay? So that should be very clear. Now this is my integration, cos theta dash sin theta dash d theta dash r square plus r square minus 2rr cos theta dash. I was very surprised to see that this question is of 15 marks. It shouldn't be. It should be a 20 marker question. ये जितना lengthy इसका calculation है, it does not deserve to be as a 15 marker question. अब थोड़ा सा हमको substitution करना पड़ेगा यहाँ पे. नीचे आपको दिख रहा है cos theta dash है, ऊपर cos theta dash sin theta dash दोनों है. u को मान लो cos theta dash. So sin theta dash d theta dash becomes du. Your integration becomes du by r square plus r square minus 2rru. 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 Integrate that. Theta is equal to 0 versus theta is equal to pi. Right? Sorry, theta is equal to this should be 1 to minus, this should be minus 1 to 1. ठीक है, this is, so यहाँ पे minus है, I remove that minus, my integration becomes minus 1 to plus 1. So do this. Now this is my final formula, this is my final derivation. 3r square plus r square r minus r mod, again r plus r. So if I am talking about points which are outside sphere, then that r minus r will be positive, and otherwise it will be negative. And do this for r greater than r, ये जो पूरा लंबा सा expression दिख रहा है, that will reduce to this 2r by 3 capital R square, and for r smaller than r, it will reduce to 2 capital R by 3 small r square. R is constant. तो आपको दिख रहा है कि थोड़ा बहुत similar सा आ रहा है. जब हम इलेक्ट्रिक पोटेंशियल भी निकालते थे, कुछ ऐसे निकल के आता था, या इलेक्ट्रिक फील्ड में कुछ ऐसे निकल के आता था. समथिंग सिमिलर इज ऑल्सो कमिंग आउट हियर. एंड ओमेगा क्रॉस आर इज ओमेगा आर साइन साई. सो दिस इज माई फाइनल वैल्यू, म्यू नॉट आर सिग्मा बाई 3 ओमेगा क्रॉस आर, एंड म्यू नॉट आर 4 सिग्मा 3 आर क्यू ओमेगा क्रॉस आर. तो यहाँ पे हमने ओमेगा क्रॉस आर को इंक्लूड कर लिया है. सो माई vector potential is proportional to r, and in this case if it is outside sphere, my vector potential is proportional to r square, because यहाँ पे देखो this is omega cross r and यहाँ पे r cube है. So my vector potential का जो mod होगा, जो magnitude होगा, that is proportional to 1 by r square. And it can be shown that अगर हम same चीज़ अगर हम ऐसे लिखते, ये आप करा नहीं है मैंने, I have mentioned it here, but अगर ओमेगा को हम मान लेते z axis के along और r कोई random r theta phi होता, then ये हमारा formula होता. This can be shown. I have not done it. You do not have to do that at all in examination. I have just mentioned it here that this is what the solution will be. And in the end, I have simply make a small diagram. I have taken mod of vector potential. This is r. inside the spherical shell, it is proportional to r, and outside spherical shell, it is proportional to 1 by r square, right? So this is the final calculation. So this is not at all an easy question. This is a difficult question, and this question ideally should be a 20 marker question. अगला क्वेश्चन भी बहुत ही मुश्किल है, बिल्कुल ही आसान नहीं है. A circular ring of radius r lying on the xy plane and centered at the origin carries a uniform line charge lambda. Find the first three terms monopole, dipole and quadrupole of multiple expansion of potential V r theta. तो जो multiple expansion है खुद में ही एक, जैसे आप जब करते हो multiple expansion, this is what we do, that let's say I have some random charge distribution. I choose this is as my coordinate system. Let's say that due to this charge distribution, I want to calculate potential at a point r here. I choose a d tau, a volume element on this charge distribution at some r, at some angle alpha. And then I calculate that इसके कारण क्या होगा, potential, and then I integrate that throughout this volume, and I want to know that what will be the total potential. When you do this calculation, you find a very nice relationship, and the relationship looks something like this. You find this relationship that I can think of a charge distribution, कोई भी shape का हो, continuous or discontinuous, doesn't matter. Any shape charge distribution, you can think of it like as a sum of different type of charge distribution. This is sigma from n is equal to 0 to n is equal to infinity. 1 by r to the power n plus 1, r dash was that distance from the volume element. P n cos alpha, what is P? ये जो px हम लिखते हैं किसके कॉन्टेक्स्ट में लिखते हैं? ये बहुत बार आता है आपका क्वांटम मैकेनिक्स में भी आएगा, ये इलेक्ट्रोमैग्नेटिज्म में आएगा. दिस इज कॉल्ड लेजेंडर पॉलिनोमियल. लेजेंडर पॉलिनोमियल का अपना खुद का एक फॉर्मूला है. सो p हियर रिप्रेजेंट्स लेजेंडर पॉलिनोमियल, रो रिप्रेजेंट्स माय वॉल्यूम चार्ज डेंसिटी एंड d tau dash. अब इसको आप एक्सपैंड करो, तो पहले तो इसका हम सिग्निफिकेंस देखते हैं कि है क्या. ये जो पूरा टर्म है इसका हम सिग्निफिकेंस देखते हैं. चूज n इज इक्वल टू 0. If I start with n is equal to 0, what do I get? I get 1 by 4 pi epsilon naught. N is equal to 0, this is 1 by r. N is equal to 0, this is 1. N is equal to 0, this becomes 1. So I do not have to worry about this. Isko hata do. And this becomes, what is first Legendre polynomial, do you remember? What is P0? Is 1. P0 is 1. P1 is x. P2 is 3x square minus 1 by 2. इतना 3 तक तो पक्के से याद रखना चाहिए. You should remember the first three values of Legendre polynomial. You'll have to use it. And there is a very nice way Legendre polynomials are formed. उसके लिए एक differential equation आपको देखना पड़ेगा. There is a very nice way these polynomials arrive from. So this becomes 1. This becomes 1. And I have rho r into d tau. Now what is rho r d tau? If I integrate that, ये क्या है? Total charge है. ये क्या है? This is nothing but total charge. So I can say that this is q by 4 pi epsilon naught r. अब ये क्या है? What I have assumed here? I have assumed that the entire charge is located at a particular point. This is called monopole. So if I have a charge distribution, मान लो ये मेरा body है. It's a very irregular body. If I go very far away, then I can assume that all of this charge is concentrated at one point, and at very far away distance I can assume that this is nothing but one single charge. It is a monopole, it is a point charge, and I can calculate the potential due to this single charge. Because think about it, अगर इसका जो next term होगा वहाँ पे 1 by r आ जाएगा. and if my r is very large, then 1 by r is going to be very small. तो नेक्स्ट टर्म का जो कॉन्ट्रीब्यूशन है वो बहुत ही कम हो जाएगा, ठीक है. बट अगर हम जैसे जैसे पास आते चले जाएं, देन आई हैव टू टेक दैट 1 by r ऑल्सो. थोड़ा और पास हम आ जाए, आई हैव टू टेक दैट 1 by r square also. The point is that this expansion, multiple expansion, it allows you to do certain approximations. Depending upon how far you are calculating this potential, even if it is a very irregularly shaped charge distribution, you can always assume that it comprises of a monopole. You can think of this as first as a monopole, then as a dipole, then as a quadrupole, then octupole, and all of that, and you can calculate potential, and depending upon what is your R, you can include more and more terms, right? So अब ये question देखो, ये this is a general charge distribution. This is going to be, ये जो formula है, ये किसी भी charge distribution के लिए true है. The question is now saying, and why I said that this is a difficult question, आप देख भी सकते हो कि 20 मार्क का क्वेश्चन है, और ये भी क्वेश्चन पहली बार पूछा यूपीएससी ने. आप पिछले 15 साल का क्वेश्चन उठा लेना, 20 साल का उठा लेना, दिस क्वेश्चन हैज नेवर बीन आस्क्ड. दिस वाज आस्क्ड फॉर द फर्स्ट टाइम, आई थिंक दिस इज 2023. ये इधर 2022 और 2023 का पेपर है. तो इसको हम कैसे सॉल्व करेंगे? पहले तो मेरा अरेंजमेंट देखो, ये है, दिस इज माई अरेंजमेंट. रीड द क्वेश्चन केयरफुली. Multiple expansion VR theta. I'm not assuming a axial symmetry. क्वेश्चन थोड़ा आसान फिर भी तब होता अगर मेरा ये जो पॉइंट है वो यहाँ पे रहता, इसके एक्सिस पे रहता. यूपीएससी ने ये भी छोड़ दिया इसको, नहीं है. दिस पॉइंट इज एट सम रैंडम आर थीटा. सो लेट्स एज्यूम दैट माई रिंग इज ऑन द XY plane and vertical is here, Z axis. This is my assumption. यहाँ पे वॉल्यूम चार्ज नहीं है, लाइन चार्ज है. सो लाइन चार्ज में जहाँ पे भी रो डी टाउ है, दैट विल बिकम लैम्डा DL. ये याद है आपको? सरफेस चार्ज में इट बिकम सिग्मा DA. सो पॉइंट चार्ज, लाइन चार्ज में लैम्डा DL, सरफेस चार्ज में सिग्मा DA, वॉल्यूम चार्ज में रो डी टाउ. सो वेर एवर आई हैव रो डी टाउ, आई हैव टू रिप्लेस दैट विथ लैम्डा DL. So this is my, let's say I will start with that at some angle phi dash is my azimuthal component, that at this phi dash I take a line element and then I integrate that phi dash over this entire integration. I look at the different terms. So for a line charge, the first thing is that rho r dash d tau dash becomes lambda r dash dl dash. अब dl dash क्या होगा? dl dash will be nothing but r d phi dash. ये बहुत क्लियर होना चाहिए. जैसे आप देख सकते हो that ये मेरा phi dash है. I take a element, small element here with angle, this angle is d phi. So length of this element is r d phi dash. So this is what I have written here, that lambda r dash dl dash is nothing but lambda r d phi dash. In spherical coordinate system, at random point r can be expanded as r sin theta cos phi ex, r sin theta sin phi ey, and z is r cos theta ez. And r dash essentially is a point on the ring itself, which is in xy plane. So since it is in xy plane, I do not have to worry about, I can simply write r dash as r cos phi dash ex, r sin phi ey. अगर आप दोनों का, why I am taking this dot product, because I want to take that alpha, एक जो alpha term था उसको हमको represent करना है phi और phi के term में, that there is a alpha there, right? So for that I took the dot product r sin theta cos phi dash, r sin theta sin phi dash, and r dot r dash, r और r के बीच का जो angle है वो alpha है. So this dot product is nothing but r cos alpha, which is same as this. So I find a relationship that जो alpha है वहाँ पे cos alpha, that is sin theta cos phi dash sin theta sin phi dash. Now I am ready to start my calculation. तो monopole के लिए क्या होगा? Q is nothing but lambda r 0 to 2 pi d phi dash, 2 pi r lambda dash. या directly भी मैं लिख सकता था, circumference is 2 pi r, line charge density is lambda, total charge is 2 pi r lambda dash. तो मोनोपोल टर्म तो बहुत सिंपल है. V naught 1 by 4 pi epsilon naught Q by R. And Q यहाँ पे 2 pi R lambda है, so monopole term is lambda R by 2 epsilon naught R. This part is very very simple. अब डाइपोल में एक आप ट्रिक लिख सकते थे, अगर आप लिखोगे भी तो नंबर नहीं कटता आपका, लेकिन ये ट्रिक तब काम करता अगर ये एक्सियल सिमेट्री रहता. जैसे मान लो सेम क्वेश्चन रहता कि आप एक्सपेंशन करो ऑन जेड एक्सिस, तो अगर हम जेड एक्सिस पे एक्सपेंशन करें तो थीटा विल ऑलवेज बी 90 डिग्री and cos theta will always become 0, right? And then I can say, I can also make a physical argument that due to this symmetry, the net dipole moment at the center is 0. For every r I have a minus r, and the net dipole moment here is 0. So hence dipole term will be 0. Can we say this also for a random point? It's not on z axis, it is some random r theta. Can we say that? So let's see. For dipole term n is equal to 1, मेरा जो इंटीग्रेशन है वो क्या होगा, r dash cos alpha rho r dash d tau. Now rho r dash d tau will be replaced with lambda r d phi dash, and r dash cos alpha will be replaced with capital R cos alpha. But I just showed that cos alpha is nothing but sin theta cos phi dash sin phi dash. Is this very clear that what is the difference between phi dash and phi here? Just in case, if it is not very clear that what is the difference, पहले तो theta क्या है? Let's in fact be very clear about all the terms I am using. Theta here is this angle with z axis. That should be very clear. That is my theta. Okay. What is my phi? Phi is the coordinate of this particular point. So this is r, theta and phi. But my phi dash is, I am taking a random element at some angle phi dash. This is on the ring itself. So phi dash I am choosing for the ring, and that has nothing to do with this phi. This phi is a random point in space somewhere, but phi dash is always and always represents a particular coordinate on this particular ring. So that should be very clear. Now what is alpha? Alpha is the angle from here to here. Right, so and this alpha I am representing with help of that phi and phi dash. So when I take n is equal to 1, r dash cos alpha rho r d dash, r cos alpha lambda r d phi dash. So v1 will be nothing but lambda r square sin theta. I have to integrate phi dash from 0 to 2 pi, जो अभी हमने वहाँ पे भी किया था. And when I do this integration, I find, remember this is cos phi, this is sin phi, 0 to 2 pi, this is 0. So that argument about symmetry holds even at some random r theta. It does not hold only for z axis, but it also holds true if you are not on the z axis. So I have mentioned that my dipole term becomes 0. This can also be deduced from symmetry. The net dipole moment vanishes as for every element r dash, there is an opposite element minus r dash. So my dipole, ये जो symmetry वाला मेरा जो argument है, that holds true even at some random r theta. Now quadrupole term, why this question is difficult, because the third part you have to derive now is quadrupole term. Now for quadrupole term, I have n is equal to 2. My integration I have to calculate, that is r dash square now. Legendre polynomial का जो third part है p2 cos alpha, which is will be 3 cos square alpha minus 1 by 2. Rho r dash d tau, उसको हमको replace करना पड़ेगा lambda r d phi dash से. p2 cos alpha is nothing but 3 by 2 cos square alpha minus 1 by 2. That you need to remember that p2x is 3x square minus 1 by 2. ये आपको याद रखना पड़ेगा. And r dash square is nothing but r square. So now do this integration. This is lambda rq cos alpha का value put करो. 3 sin square theta cos phi dash sin phi dash square minus 1. 2 को मैं बाहर लेके आ गया. So lambda rq by 2. अब ये हमारा पूरा इंटीग्रेशन है. Lambda rq by 2, 3 sin square theta cos square phi, 0 to 2 pi cos square phi dash. Now this is cos square. अगर cos phi dash रहता तो ये 0 रहता, but ये cos phi dash नहीं है. This is cos square phi dash. Similarly there that is sin square phi dash. ये अभी भी 0 होगा. Remember this is sin phi dash cos phi dash, that is nothing but 2 sin phi 2 phi dash, or 1 by 2 2 sin phi. तो ये तो अभी भी 0 होगा. So do all of that. 3 sin square theta. This is pi. We know that this is pi. So this is pi. Pi cos square phi, pi sin square phi. So pi cos square phi, pi sin square phi is nothing but pi. So this is 3 pi sin square theta minus 2 pi. अब pi कॉमन ले लो एंड पाई आप यहाँ पे लेके आ जाओ. So this is pi lambda rq by 2, 3 sin square theta minus 2. But now again it is becoming another Legendre polynomial. So अब 2 को मैं इधर लेके चले जाऊँ. So this becomes, अगर मैं इसको अरेंज इस तरीके से कर दूँ sin square theta को 1 minus cos square theta के फॉर्म में, then this becomes minus pi lambda rq 3 by 2 cos square theta minus 1 by 2, which is nothing but p2 cos theta. That is my Legendre polynomial. So what is my quadrupole moment? What is my quadrupole term in the entire expansion? Lambda by 8 epsilon naught rq by rq 3 cos square theta minus 1, or I can 3 cos square theta minus 1 by 2 को I can write this as p2 cos theta. तो ये part जो है मुश्किल था. And hence you can see this is a 20 marker question. So this was not at all an easy question. ये derivation देखना और ये solution पता होना इसलिए ज़रूरी है कि आप एग्ज़ाम में इसको रिजेक्ट कर सको. ये क्वेश्चन नहीं करना है. 20 मार्कर क्वेश्चन तो कोई भी जब भी आप कंपलसरी क्वेश्चन चूज़ करते हो, आउट ऑफ सॉरी जो नॉन कंपलसरी क्वेश्चन हैं उसमें भी तो चूज़ करना है आपको. सो व्हेन यू आर चूजिंग दैट, हैविंग दिस नॉलेज दैट नो दिस इज नॉट, दिस शुड नॉट बी डन. अगर ये 10 नंबर का रहता, बहुत मुश्किल रहता, लग रहा है कि आई डू नॉट नो हाउ टू सॉल्व इट और इट विल टेक लॉट ऑफ टाइम, बट इट ओनली हैज़ 10 मार्क्स. आई नो दी अदर 40 मार्क्स. हर क्वेश्चन 50 नंबर का है. आई नो दी अदर 40 मार्क्स. If that's the case, you can go ahead and do that. 10 नंबर आप sacrifice कर सकते हो. If you are very confident about the other 2 part, that you can do that in a limited time frame. But if it is a 20 mark question, then don't sacrifice that. For 30 marks, don't like sacrifice that 20 marks. So you should know that this is a question, even if I try and I will be able to solve it, it is going to take time first. And second, there is always a chance that I will get stuck somewhere in between. So knowing about this derivation, understanding this topic is to understand while in examination that I am not going to attempt this particular question. Next is a easy question. Two charge Q1, Q2 are located at Cartesian points 0, 2, 2, 0, minus 2, 4. Z equal to 0 plane is a connected to the ground. इन्होंने मेंशन नहीं कर रखा है बिकॉज इलेक्ट्रिकल इमेज का प्रॉब्लम है. इमेजिन दैट दिस Z is equal to 0 is a conducting plane. It is an infinite conducting plane and that is connected to the ground. आइडियली ये इनको मेंशन करना चाहिए था. ठीक है. कैलकुलेट द इलेक्ट्रिक पोटेंशियल एंड इलेक्ट्रिक फील्ड एट पॉइंट 324 यूजिंग द मेथड ऑफ इमेजेस. ओके, ये बहुत सिंपल है. मेथड ऑफ इमेजेस का काम करने का सिंपल सा तरीका है. ये मेरा देखो स्ट्रक्चर है. This is my xy plane, this is my z axis. I have a charge 0 to 2, x coordinate is 0, y and z. So one of the charge is in yz plane, another charge is also in yz plane 0, minus 2, 4. And the z is equal to 0 plane, which is essentially xy plane. Xy plane is a infinite conducting plane which is connected to, which has been earth, right? Okay. तो इसका पोटेंशियल 0 होगा यहाँ पे. आई नो दैट दिस पोटेंशियल इज गोइंग टू बी 0 बिकॉज दिस इज कनेक्टेड टू द अर्थ. ये मेरा डिस्ट्रीब्यूशन है. बिकॉज ऑफ दिस 2 चार्जेस देयर विल बी सम सरफेस चार्ज डेंसिटी विच इज गोइंग टू हैपन हियर. सो बिकॉज ऑफ दिस सरफेस चार्ज डेंसिटी ऑफ दिस इनफाइनाइट कंडक्टर प्लस दिस 2 चार्जेस, व्हाट विल बी द पोटेंशियल एट अ पर्टिकुलर पॉइंट. इट मे सीम लाइक दैट ये कैसे कैलकुलेट करें. अगर खाली ये 2 चार्ज रहता, ठीक है, then it is a very easy question. But ये खाली 2 चार्ज तो नहीं है. So how should we calculate this? And this is where electrical images come into place. That if I replace this arrangement in a way that my boundary conditions are satisfied, and my boundary condition here is that at z equals to 0, my potential should be 0. Everywhere my potential should be 0. So if my boundary condition is satisfied, then even with that next charge distribution, I can do all sort of solutions. जैसे देख लो आप, मैंने इसी का एक दूसरा अरेंजमेंट बनाया. ये Q1 0 to 2 पे था, तो मैंने माइनस Q1 0 to minus 2 पे एक प्लेस करा. Q2 0 minus 2 4 पे था, तो मैंने यहां पे Q2 0 -2 -4 पे प्लेस करा. नाउ लुक एट एनी पॉइंट, चूज एनी पॉइंट ऑन दिस प्लेन. यहां पे मेरा बाउंड्री कंडीशन क्या था? दैट V शुड बी 0. बट यहां पे देखो, कोई भी पॉइंट मैं यहां पे ले लूं, इसके कारण जो पोटेंशियल होगा और इसके कारण जो पोटेंशियल होगा दैट विल कैंसल आउट. सिमिलरली इसके कारण जो पोटेंशियल होगा और इसके कारण जो पोटेंशियल होगा दैट इज गोइंग टू कैंसल आउट. तो माय बाउंड्री कंडीशन V इज इक्वल टू 0 एट एनी XY पॉइंट दैट इज गोइंग टू बी satisfied. सो अब ये क्वेश्चन बहुत आसान है. अब क्वेश्चन में क्या है कि एट सम पॉइंट 342, what is the question? That at some random point 324 I have to calculate electric potential and electric field. So I have done that. I have made this entire argument. I will do that by the way. 15 mark का question है. So I will make this entire argument कि ये मैंने क्यों करा है. I want to satisfy my boundary conditions. And once I do that, then this is a very easy question. One more thing. Electrical image problem will only work if you are above the conducting ground. ये नीचे नहीं काम करेगा. नीचे it is not going to work. It is only going to work for a point above that. But look at 324, that is in a positive first quadrant. So I do not have to worry about that problem. So now my potential has to be all of those four charges. Qi by R minus Ri. तो बस हमको ये R minus Ri का ध्यान रखना पड़ेगा कि that is x2 minus x1 square, y2 minus yn square, z2 minus z1 square. ये हमको खाली ध्यान रखना पड़ेगा. Do all of that sum. I get this potential 6.85 volt. This is now simple arithmetic. ऐसे क्वेश्चन में I was talking about that you should be very careful. जैसे एक आप immediately देख सकते हो कि ये 9 into 10 to the power 9 है, 10 to the power 9 आंसर से खत्म हो जाएगा. So this is nothing but 9. अब ये 9 into 3 है, 9 into 4 है, 9 into minus 3 है, 9 into minus 4 है. But numerator तो अलग अलग है, डिनोमिनेटर अलग अलग है. तो उसके हिसाब से फिर आपको देखना पड़ेगा. दिस इज स्क्वायर रूट 13, दिस इज 5, 45 एंड 89 एंड दिस इज माय आंसर. फॉर इलेक्ट्रिक फील्ड इट विल बी लिटिल बिट मोर डिफिकल्ट बिकॉज फॉर इलेक्ट्रिक फील्ड आई ऑल्सो हैव टू नाउ टेक केयर ऑफ कि डायरेक्शन क्या है. वेक्टर देखना पड़ेगा. फील्ड तो वेक्टर है, तो वेक्टर के लिए आपको पूरा ये निकालना पड़ेगा कि जो यूनिट वेक्टर है आर माइनस आर आई वो क्या होगा. एंड देन यू हैव टू डू दिस वेक्टर एडिशन इन द एंड. And this is my electric field also. अब देख लेना calculation. This is a simple arithmetic. ठीक है. Last two questions. हमारे पहले टॉपिक में ही 2 घंटे हो गए. We still are at the very first topic itself. Last two question. ये इस साल का क्वेश्चन है दोनों. In spherical coordinates, V is equal to minus 25 volt on a conductor at R is equal to 2, V is equal to 150 volt, another conductor R is equal to 35. The space between the conductors is a dielectric for which epsilon R 3.12 is given. Find the surface charge density on the conductor. So this is like a spherical capacitor we have read, but the only thing is that in this spherical capacitor, you have a dielectric medium. So this is a spherical capacitor. But in between I have a dielectric medium जहाँ पे epsilon r कुछ यहाँ पे दे रखा है. तो ये कैलकुलेशन बड़ा सिंपल होता है. वोल्टेज देखो दे रखा है यहाँ पे. वोल्टेज इज फॉर r इज इक्वल टू 150 वोल्टेज, v इज इक्वल टू -25. ये -25 पे जो स्मॉलर मेरा स्फेयर है, लेट्स कॉल दिस RA, एंड ये है मेरा 150 वोल्टेज पे. ओके, कैसे करेंगे इसको? सिंपल सा होता है कि हम इफ आई गिव सम प्लस क्यू हियर देन देयर विल बी माइनस क्यू आउटसाइड, बिकॉज आई एम एज्यूमिंग दैट दिस इज इन अ आइसोलेटरी कंडीशन. ये किसी स्पेस में कहीं पे है. चार्ज ऑलवेज हैज टू बी कंजर्व्ड, राइट? So if I have some free charge plus q here, there will be free charge minus q on the opposite surface. But where should I have plus charge, where should I have minus charge? I have plus q and minus q. देखो 2 नंबर तो खाली इस बात को डिसाइड करने के. इस क्वेश्चन में 2 नंबर कम से कम इस बात के मिलेंगे आपको कि अगर आपने प्लस क्यू माइनस क्यू गलत कर दिया तो आपका गलत हो जाएगा. कहाँ पे माइनस क्यू होगा, कहाँ पे प्लस क्यू होगा, कैसे करेंगे डिसाइड हम? I will use the concept of electric field. Electric field emerges from positive charge and towards negative charge. And electric field का जो डायरेक्शन है उस डायरेक्शन में हमेशा पोटेंशियल घटेगा. तो पोटेंशियल कहाँ पे घट रहा है? ये हाई पोटेंशियल पे है, ये लो पोटेंशियल पे है. So potential is going to reduce in this direction. So electric field direction should also be in this direction, which means that there should be plus Q here and there should be minus Q here. अब क्वेश्चन बहुत सिंपल है. आई सिंपली हैव टू राइट व्हाट इज द पोटेंशियल हियर ड्यू टू दिस फेयर एंड उसको इंटीग्रेट करो RA टू RB. बस ध्यान रखो कि दिस इज अ डाइइलेक्ट्रिक मीडियम. सो आई मेंशन दैट. थोड़ा सा जल्दी करते हैं. आई थिंक we'll have to maybe continue this in some other, because I'm very sure there will be some class here at 5 o'clock at this particular center. So हम 4:40 4:45 तक कर सकते हैं. A is given, B is given, potential is given. This is like a spherical capacitor. If I assume minus Q and plus Q for the inner conductor and outer conductor, and there is a reason I have done that, because I want to ensure that मेरा potential जो है वो गड़बड़ ना हो. So I have to calculate V2 minus V1, A to B ER, and in this case that ER will be 1 by 4 pi epsilon. Remember, it will not be epsilon naught because it is a dielectric, and epsilon is epsilon naught, epsilon R. Epsilon R is given in this particular question. So V2 minus V1 is nothing but Q by 4 pi epsilon 1 by A minus 1 by B. V2 is 150, V1 is 25, minus 25, so this becomes 175. Q by 4 pi epsilon R epsilon naught 1.1 by 0.02, 1 by 0.05. Everything else is known. I only do not know Q. Calculate Q. Q turns out to be 1.29 nanocoulomb. And based on that, calculate the surface charge density. This will be 4 pi 0.02 square and 4 pi 0.35 square. One will be negative, another will be positive. Smaller charges, smaller sphere, negative, outer sphere, पॉजिटिव. सो अगेन एक पेज का सोल्यूशन है, बट ये जो खाली ध्यान रखना है कि प्लस क्यू माइनस क्यू, उसके भी आपको नंबर यहां पे मिलेंगे. अगला क्वेश्चन बहुत सिंपल है. द मैग्नीट्यूड ऑफ द एवरेज इलेक्ट्रिक फील्ड normally present in Earth's atmosphere just above the surface is 150 Newton coulomb per coulomb, directed radially towards the center of Earth. What is the total net surface charge carried by Earth? Assume Earth to be conductor. So this is very easy. We simply apply Gauss's law. We know that due to Gauss's law, for a spherical charge system, I can assume that this entire charge is concentrated at the center. अच्छा, by the way, एक और बहुत important point ये है that ये inward field है. तो अगर inward field है, that means that on the surface I have negative charge. It should be very clear. And why I am only showing on the surface? Because it is saying that it is a conductor. I am assuming Earth to be a conductor. Inside conductor I cannot have charges. ये पढ़ा होगा आपने, that inside conductor I cannot have charges. So anyways, this is the net charge here is a negative charge. I use Gauss's law, which is simple. Electric field is nothing but Q by 4 pi epsilon naught R square. E is given here. Just at the surface, R is nothing but radius of Earth. So Q is 4 pi epsilon naught R square E. Do all of that. This is the charge. I mentioned this. Radial inward field signify negative charge. So total charge is minus 6.7 10 to the power 5 coulomb. So this is like also a very, very easy question which you can expect. Anyways, we still are in tutorial 1. If you have any questions in tutorial 1, you can ask questions. If you have any doubt anywhere, any concept. So you'll realize that except those two questions which I discussed in between, rest of the questions were frankly not very easy, straightforward. But yeah, somewhere in between you can find difficult questions also. ये एक स्टैंडर्ड क्वेश्चन है जो यूपीएससी, आई एम नॉट वेरी श्योर हुआ ये 10 नंबर में क्यों पूछा हुआ है. ये 10 नंबर का क्वेश्चन कहीं से नहीं है. एंड जस्ट बिकॉज आपने खाली आर लेस देन ए पूछा है तब भी ये 10 नंबर का नहीं है. अगर आप आर लेस देन ए है तब भी इट शुड बी एटलीस्ट 15 मार्कर क्वेश्चन. एंड इफ यू आर आस्किंग बोथ ऑफ दैट देन इट शुड बी डेफिनेटली अ 20 मार्कर क्वेश्चन. इट विल बिकम वेरी क्लियर. ये बाउंड्री कंडीशन वाला तो क्वेश्चन हमने कर लिया. सॉरी, वी आर स्टिल इन ट्यूटोरियल 1 ओनली. सॉरी, वी आर सम क्वेश्चंस ऑफ मैग्नेटोस्टैटिक्स. ये हमने कर लिया था और एक क्वेश्चन ये रह गया. ठीक है, जल्दी से खत्म करते हैं इसको. There is a uniform magnetization. I have to calculate the scalar magnetic potential. Phi हमको calculate करना है, not vector potential, but scalar potential. Magnetization is uniform along z axis. जो current density होगा, volume current density, that is nothing but del cross m. That is going to be 0. And if j is 0, del 2 phi is going to be also 0. So this is my equation. I got the equation del 2 phi. Now immediately, I have not done it, but it can be shown that if I have a function like this, del 2 phi is equal to 0, then general solution is again that Legendre polynomial form. This is going to be general solution. ये खुद का अपना 2 पेज का derivation है, that why would it be. ये यहाँ पे इस क्वेश्चन में बिल्कुल नहीं करना. The complete solution will be AL r to the power L PL cos theta. L is all the positive integers including 0 plus BL divided by r to the power L plus 1 PL cos theta. That is the complete solution. But why I have bifurcated this solution? Because if I take the complete solution inside that sphere, then at r is equal to 0, ये जो next वाला है ये इनफाइनाइट हो जाएगा. रिमेंबर यहाँ पे r जो है डिनोमिनेटर में है, b by r to the power l plus 1. So that cannot be correct. Okay. And if I take outside solution, then for very large r, this is going to be again infinite. So I choose inside sphere, I choose this solution. Outside sphere, I choose this solution. That is to ensure that my magnetic potential does not become infinite. Right. So I do this. And when I do this, I also use now my boundary conditions that potential must be a continuous function at r is equal to a. So AL a to the power L PL cos theta, BL a to the power L PL cos theta, that should be same. Now look closely here, L is same here. So since L is same here, I can remove PL cos theta, PL cos theta. So this becomes nothing. AL into a to the power L should be BL divided by a to the power L. So I find a very nice relationship. BL is equal to AL into a to the power 2L plus 1. This is my first equation. Another thing which you should know, that if magnetic surface charge density is given, then this is how there is a discontinuity for scalar magnetic potential. And that discontinuity is del phi by del r minus del phi by del r. And that is equal to minus sigma m. And sigma m is magnetic surface charge density. And sigma m in this particular case will be m dot er, which will be m naught cos theta. अब इसको आप यूज करो, फाई दे रखा है आपका, आप यहाँ पे डी फाई बाई डी थीटा निकालो, यहाँ पे डी फाई बाई डी थीटा निकालो, सॉरी एल आर निकालो, डेल फाई बाई डेल आर निकालो, यहाँ पे डेल फाई बाई डेल आर निकालो. डू दिस डिफरेंशिएशन. So when I differentiate outside points minus L plus 1, BL A by L plus 2, this was L plus 1, so L plus 2, PL cos theta, minus LAL minus 1 PL cos theta, that should be equal to minus M cos theta. अब आप immediately यहीं पे आप देख सकते हो कि ये जो मेरा term है, it is saying that L can be from 0 to infinity, जो मेरा LHS है, but RHS जो मेरा बोल रहा है वो बोल रहा है कि नहीं, I can only have cos theta. That means, अब यहाँ पे हमारा जो Legendre polynomial का पूरा जो information है, that will be helpful. For Legendre polynomial, P0x is 1 and P1x is x. Here, that x is cos theta. So P1 cos theta is cos theta. So that immediately tells you that यहाँ पे L कुछ भी नहीं हो सकता. L can only and only be 1. Because my RHS has cos theta and my LHS is saying that it can be cos square theta also, cos q theta also, cos 4 theta also, but my RHS is telling no, that is not possible. So the only value I choose here is L is equal to 1, right? Given the magnetization, constant magnetization, only possible value is L is equal to 1. I mentioned that. I find another relationship by the way. I use that AL and BL ka relationship. I put all of that and I find this very nice relationship. 2L plus 1 AL A to the power L minus 1 PL cos theta is M cos theta. So that immediately tells me that LHS and RHS can only be equal for L is equal to 1. P1 cos theta is equal to cos theta. And when I choose L is equal to 1, now everything is shorted. 2L plus 1, L is 1. Into A1 is M naught. वहाँ से A1 मेरा आ गया M naught by 3. And A1 B1 का relationship हमको पहले से पता था. B1 भी आ गया M naught by 3 AQ. And जो मेरा final potential है for R less than 1 is M naught by 3 R cos theta, which is nothing but Z. And immediately अब ये पता नहीं ये क्यों नहीं पूछा. जब मैंने इतना derive किया ही है, A1 B1 सब कुछ निकाल ही लिया है, तो बस एक लाइन में मुझे लिखना है कि for R greater than 1 it will be M naught by 3 AQ by R square cos theta. Right? So ये best तरीका है इस क्वेश्चन को सॉल्व करने का. There is one more method you can solve this, but that is going to take longer time. ये बेस्ट तरीका है इसको सॉल्व करने का. यूज लेजेंडर पॉलिनोमियल. एंड सबसे फैंटास्टिक पार्ट जो है इस पूरे सॉल्यूशन में वो ये पार्ट है दैट गिवन दिस कांस्टेंट मैग्नेटाइजेशन, अगर m का कोई और फॉर्म होता, देखो यहां पे m जो है वो कांस्टेंट है, m नॉट z है. अगर m का कोई और फॉर्म होता then accordingly my L would have included other parameters also. But given the m in this question, L can only take the value of 1. This is the best part. ये पूरा का पूरा इतना difficult सा जो दिख रहा था, it reduced to a very simple solution. ये हमने कर लिया था already. Now this is the last question of tutorial 1. This is a very simple question that I have a square loop of electric current and I have to calculate the magnetic field at the center of that square. तो बहुत easy है. If I choose this clockwise direction of magnetic field, then this magnetic field is going to be inside this, and because it will be same for all the points and this point is equidistant from all of this current, it is nothing but 4 times magnetic field due to 1 of the current. And we already know that if I have a wire like this and at a particular point which makes angle alpha and beta, then magnetic field is mu naught I by 4 pi r sin alpha sin beta. ये आपको derive करने की ज़रूरत नहीं है. वैसे तो ज़्यादा लंबा derivation नहीं है, but इस question में आपको derive नहीं करना. 10 नंबर का question है, ये भी ध्यान दे के रखना है कि ये derive करने लगोगे कि गड़बड़ हो जाएगा. ठीक है. अब यहाँ पे क्या है, अल्फा बीटा 45 डिग्री है, r जो है l by 2 है. Put all of that. This is due to 1 of the current and this is due to all of the electric current, 2 root 2 mu naught I by pi l, and h भी निकालना है. h is nothing but b by mu naught 2 root 2 I by pi l. हो गया, निकल गया हमारा. So this is a very simple question you can expect. Okay, now let's directly go to tutorial 2. Let's look at some of the questions. This is easy. This part is much more easier compared to tutorial 1. First is a question which you learned even in your class 11th. आप अपने engineering preparation के time आपने पढ़ा होगा. This is the circuit. I have 2 parallel batteries. Question का जो पूरा statement है देखो आप. Internal resistance 1 ohm, 1.5 voltage. Another cell of internal resistance 2 ohm, 2 voltage are connected in parallel across the end of a external resistance of 5 ohm. Find the current in each branch of the circuit. So this is my arrangement. 1.5, 1 m, 1 ohm, 2 voltage, 2 ohm and 5 ohm. I use Kirchhoff's law. Let's assume that this supplies I1, this supplies I2. So net current is I is equal to I1 plus I2. That is Kirchhoff's law of current. अब 2 तरीका था वोल्टेज को यूज करने का. इस लूप में मैं यूज करता 0 लिख लेता, इस लूप में मैं लिख के 0 लिख लेता, तो मेरे पास 2 अननोन 2 इक्वेशन आ गए. बट एक और तरीका हो सकता था, और सिंपल तरीका ये है कि इसके अराउंड वोल्टेज देखो क्या होगा. इफ I1 इज फ्लोइंग थ्रू इट, देन इसके अराउंड वोल्टेज क्या होगा, E माइनस I1 R1. इसके अराउंड वोल्टेज क्या होगा, E2 माइनस I2 R2. एंड इसके अराउंड वोल्टेज क्या होगा, I इंटू R, एंड I हियर इज I1 प्लस I2 R. ये तीनों सेम होने चाहिए बिकॉज दीज आर इन पैरेलल. सो आई यूज दिस वेरी सिंपल लॉजिक दैट वोल्टेज around first battery is 1.5 minus I1. It is same as 2 minus 2 I2, and it is same as for the external resistor I into R, I1 plus I2 into 5. हो गया हमारे पास. आप देख सकते हो कि I1 I2 अननोन है हमारे पास इक्वेशंस आ गए. सबको आप रिजॉल्व करो, सिंपल अरिथमेटिक है. I find I1, I find I2, and I is nothing but I1 plus I2. So this is like simple arithmetic. This is something which you have learned even in your class 11th and 12th class discussion. Okay, this question, this is an interesting question. यहाँ पे थोड़ा बहुत हमको थोड़ा दिमाग ध्यान रखना जरूरी है बहुत. Consider the RLC circuit shown here. अब ये देखो series RLC circuit नहीं है. It's a parallel RLC circuit where the inductor and resistor are in series, and both of them are parallel to the capacitor. ये बहुत important है. Calculate the Q factor of the circuit. What does Q factor represent? Q factor circuit का क्या represent करता है? कितना damping है essentially, कितना loss of energy हो रहा है, right? जितना Q factor कम होगा उतना ज़्यादा loss होगा. Q factor जितना ज़्यादा होगा उतना कम loss होगा. So अगर ये LRC circuit रहता उसका Q factor versus series LRC circuit रहता उसका Q factor versus इसका Q factor, there is a difference, and that is why I said that you have to be very little bit careful. That यहाँ पे जो Q factor है that is 1 by R square root of L by C. ये आपको याद रखना पड़ेगा. Again 10 marker question है, nobody is expecting you to derive that. Put all of that, you have your Q factor, which is very small here, and very small means very strong damping. अब second part है, question खत्म नहीं है. Question ये बोल रहा है that does it also have resonance? Okay, let's see. Resonance happens, you have low damping. So for resonance condition of parallel RLC circuit happens when this omega naught becomes 0, which is 1 by LC minus R square by L square. But अगर ये omega naught का solution imaginary हो तो resonance हो ही नहीं सकता. तो अब calculate कर लेते हैं. 1 by LC is 5 into 10 to the power 5, जो value दे रखा है. R square by L square is 1.6 10 to the power 7. So this is bigger than 1 by LC. This is going to be square root of negative, which simply tells you that resonant frequency is not possible in this circuit. And that makes a lot of sense also. This is an overdamped circuit. There is an excessive damping which is also clear by Q value. I mentioned that. There is an excessive damping. Resonance tab hoga when there is a low damping condition, energy transfer is maximum. So ये आप relate भी कर सकते हो first part और second part को. ये लिखने का आपको 0.5 marks extra मिलेगा. That you can also see this from Q value. There should be no resonance here. Okay, this is a very, very lengthy and interesting question. ये lengthy बहुत है, but question बहुत simple है. बस इसमें ये है कि ये question is not only about electricity, it also checks your knowledge of wave motion. So do you remember the value of standing wave? जब आपने standing wave पढ़ा था classical mechanics में, do you remember displacement का जो पूरा formula था? ये अगर आपका नहीं होगा तो ये नहीं हो पाएगा. Read the question. A metal guitar string with a length of 70 centimeter vibrates at its fundamental frequency. Okay, fundamental frequency का क्या मतलब होता है? That if this is my guitar string, then it is vibrating like this. This is my vibration. Okay. In a uniform magnetic field of 10 Tesla oriented perpendicular to the plane of vibration of the string. ये मेरा magnetic field है. चलो ठीक है, आगे बढ़ते हैं. क्या है? Assume a sinusoidal form, which I have done that, for the amplitude of vibrational mode and a maximum displacement of 3 mm at the center of the string. ये 3 mm है, ठीक है. I know the amplitude of the standing wave. What is the maximum EMF generated across the length of the guitar string? I have to now apply Faraday's law. But remember Faraday's law यहाँ पे जब भी आप apply करोगे, changing magnetic field producing electric field. अगर velocity same हो तो it was simply b times l times v. But यहाँ पे velocity is not going to be same. If you remember your wave motion, velocity depends upon where you are. यहाँ पे velocity अलग होगा, यहाँ पे अलग होगा. So I'll have to do integration. अभी दिख जाएगा. At what point in time in the string motion does that occur? So maximum EMF कब होगा? And what would be the EMF if the same guitar string vibrates at the second harmonic? Now what is second harmonic? Again remember, second harmonic is this. I have full sine wave. So this is my second harmonic. चलो अब देखते हैं पूरे क्वेश्चन को. पहले तो जो पैरामीटर्स हैं जो दे रखा है लिख लेते हैं. My length is given 0.7 meter, frequency is given, magnetic field is given, my amplitude is given, y maximum is given. Okay. Remember, because it is a guitar plucked at two places, it is going to produce standing wave. It will be a standing wave in the way that the two places where it is plucked, it is going to be a node, right? Remember that basic knowledge of wave motion. So this is my standard relationship. ये आपको डायरेक्टली लिखना है. आप बैठ के अब डिराइव करने लगोगे तो गड़बड़ हो जाएगा. ये डायरेक्टली लिखना है. That is y sin pi x by l cos omega t. This is my displacement at a particular point at a particular time. सब कुछ यहाँ पे दे रखा है. y नॉट दे रखा है मैक्सिमम 3 into 10 to the power minus 3. l दे रखा है pi x by 0.7. ओमेगा दे रखा है 246.94 into t. So this is, I know the relationship. For x, if x is given and at a particular time t, I can calculate y. Okay. What is vxt? Vxt is nothing but del y by del t. Take the del y by del t. This is my v. अब हमको निकालना क्या क्वेश्चन में? We have to calculate induced electromotive force, which I can use now Faraday's law. Changing magnetic field is going to produce electric field. So the total induced electric field is B V dx, and this x is not same. Remember, this is the displacement is different at different point. So I just calculated V in the form of sin pi x by l 0 by l. This is my induced EMF. अब ये पूछा क्या है क्वेश्चन में कि ये मैक्सिमम कब होगा? मैक्सिमम तब होगा when sin omega t is 1. जब sin omega t 1 हो, this is going to be maximum. And maximum value क्या होगा हमारा? b naught omega into 2l by pi. Sin omega t is 1. सब कुछ दे रखा है, करके देख लो. This will come out to be about 21 voltage. Right. So देख के लग रहा था इतना मुश्किल डरावना सा क्वेश्चन है, but the actual calculation is very very easy. But the only thing is that you have to remember that formula of standing wave. And ये कब होगा? That is also very easy. It is going to happen when sin omega t is plus minus 1. Let's take only plus 1. For minimum time, omega t should be pi by 2. Sin pi by 2 is 1. यहाँ से हमारा t पता है, t is equal to pi by 2 omega. And this is going to be happening at 1 by 1000 second, approximately 1 by 1000 second. And in general, अगर हमको देखना हो, so omega 2 should be 2n pi plus pi by 2. So t should be pi by omega 2n plus 1 by 2. 2 into 10 to the power minus 3, 2n plus 1 by 2. Put n is equal to 0, 1, 2, 3, and you get all the time where I am going to have maximum induced EMF. Okay, but the question is not complete. Question is also saying there is a second harmonic, something like this. Now, when you do second harmonic and जब आप ET जो था that was proportional to this integration, but यहाँ पे अब 2 pi है, वहाँ पे pi था, यहाँ पे 2 pi है. अब इसको integrate करो, that is going to be 0. And that makes sense also. This is now a complete sine wave. So the one part giving positive result, another part giving negative result, that cancels out and the net EMF is going to be 0. तो ये क्वेश्चन देख के बहुत स्कैरी लग रहा है, लंबा सा क्वेश्चन है, बट एक्चुअली 20 नंबर का भी है. बट अगर आपको फॉर्मूलाज खाली स्टैंडिंग वेव का फॉर्मूला अगर आपके दिमाग में था, नहीं भी था, तो उसको डिराइव करना बहुत ही आसान होता है बाय द वे. तो आप झट से इसका आंसर कर सकते हो. ठीक है, दैट वाज द पॉइंट आई वाज ट्राइंग टू मेक. This is another very simple standard question. JEE के टाइम पे भी पढ़ते थे. I remember deriving this even IIT during IIT preparation. Expression for the inductance per unit length of two long parallel wires, each of radius a separated by distance d from their axis and carrying equal and opposite current I. Okay, let's do this. I always will make a diagram. This is my diagram. This is my current 1, diameter, radius A. Radius A, at a particular point I have to calculate the magnetic field, and based on that I am going to calculate the inductance. Okay. To calculate the total magnetic flux here, that how much flux is passing through, I have to first calculate magnetic field at a particular point. The magnetic field तो बहुत simple होता है कि it is a very long current. Magnetic field will be mu naught 2 pi, mu naught I by 2 pi r from this point. And the total distance is d here. So magnetic field due to this current will be d by r, d minus r, mu naught I divided by, that is what I have written. The net magnetic field is mu naught I by 2 pi r and mu naught I by 2 pi d minus r. This is my net magnetic field. Due to this net magnetic field, I want to calculate that how much flux will pass through this small area strip I have selected at distance r and a width dr. So my length L. So total area is L into dr. Okay, so I have to calculate the flux. Flux is nothing but B into dA, mu naught I by 2 pi 1 by r, 1 by d minus r into L dr, and that now has to vary. For the first current it has to vary from A to d minus A. For the second current again it has to vary from A to d minus A. Do this calculation, very simple calculation, do all of that, and this is what you are going to find, that your flux is 2 mu naught IL 2 pi log d minus A by A, and I have to calculate the inductance. So phi, I know phi is L into I, which is mu naught IL by pi ln d minus A, I khatam, and inductance per unit length will be nothing but that L by small l. L is, remember, L was length of that aerial strip I have chosen. So this is my inductance per unit length, mu naught by pi ln d minus A by A. So बहुत ही simple question है, डेढ़ पेज का भी solution नहीं है. So you expect easy questions also in paper 2. This is another very easy question. I have two inductors in parallel and इनका mutual inductance भी है, which is shown as M. I have to calculate the effective inductance. तो अगर ये mutual inductance नहीं होता तो remember this is nothing but L1 L2 by L1 plus L2, 4 line का calculation है. But there is a mutual inductance. So because of that, what will be the effective inductance I have to calculate? So let's assume that I have I1 current along this inductor, I2 along this inductor. Total current is I1 plus I2. So I have to essentially replace this 2 inductor with an inductor, where if the effective inductance is L, let's say L effective, then I can write this as L times this I. So I'm going to do this arrangement. अब L1 के अराउंड अगर हमको वोल्टेज लिखना हो, so this will be L1 di1 by dt, yes, but there is a mutual inductance, and this will be due to di2 by dt, M into di2 by dt. And for L2, V will be L2 di2 by dt, M di1 by dt. Because these are in parallel, V will be same, right? अब आप पूरा का पूरा अरेंजमेंट है, आप इसको इक्वेट करो पहले, you get this relationship di1 by dt and di2 by dt में आपको एक relationship मिलेगा, and आप इसको total current में use करो, do all of this arrangement, and you are going to find this relationship, that your V is equal to L1 L2 minus M square, L1 plus L2 minus 2M di by dt. तो यही तो हो गया effective inductance मेरा, that I find a relationship between V and I. So my effective inductance is L1 L2 minus M square, L1 plus L2 minus 2M. And makes sense also, if M is 0, then this is nothing but L1 L2 by L1 plus L2. This is another easy question. ऐसे question देख के बहुत खुशी मिलनी चाहिए. This was a question asked in last year paper. ये भी आप HC वर्मा में दे रखा है. Motional EMF, that I have a magnetic field, there is a wire loop, and there is a wire which is given a velocity V. Because of that, it is going to produce a induced electromotive force, and you have to calculate that how this velocity is going to change with respect to time. तो बहुत ही simple question है. पहले तो आप लिखोगे पूरा. That due to sliding of the wire, imagine that what will be the force on one electron. One electron will experience the force QV cross B. अब यहाँ पे देखो, इस क्वेश्चन में पूरा देखो जो अरेंजमेंट था, V is going inside, B is going inside, V is towards this axis. So what will be the force? Force will be in this particular direction. So हमें लिखेंगे that all free electrons will accumulate at P and positive charge appears at Q. And as a result, we have an electrostatic field from Q to P, and our electron is going to experience this force Q times E. And these charges will accumulate till the point of time FB is equal to FE, and that is nothing but VB is equal to E. तो ये तो पहले हमारा रिलेशनशिप मिल गया. एंड हमारा जो पोटेंशियल डिफरेंस है, जिसको वी आर कॉलिंग इट इंड्यूस्ड इलेक्ट्रोमोटिव फोर्स, that is nothing but E times L, which is VBL. So this is called induced EMF, is called motional EMF, that this electromotive force has been induced due to motion. And induced current यहाँ से हम निकाल लेंगे E by R plus R. R is the internal resistance, BVL by R plus R. Why I calculated current? Because I have to calculate force. Remember Lenz's law, nature does not like change in flux. So a force will start operating now on that particular R, particular wire, which is IL cross B. ILB B square L square V by R plus R. अब आप clearly देख सकते हो कि ये जो F है वो proportional to V है. And remember again it is going to not like that change in flux. So that F will be opposite to V. So there is a force which is opposing your velocity, and that is an example of, classic example of retarding force. That a retarding force is going to happen. So I have calculated my acceleration as a result of that, F by m. And remember it is a retarding force. A is minus kV, K is B square L square, mr plus r. And यहाँ से आप कर लो dv a dv by dt minus kV. यहाँ से we find a logarithmic decay that v is equal to v naught e raised to the power minus kt. And यहाँ पे जो k दे रखा है हमारा b square L square m r plus r t. This is what I had to calculate. And 20 marks का है. But this is a question which should make you very, very glad that you can get 20 marks so easily, right? Let's do at least few questions of electromagnetic waves. I don't think I will be able to do all of the questions. Let's have 10 more minutes and let's end this class. Let me show you few like directly practical questions. जैसे ये तो बहुत easy है. This is like a basic derivation कि आपको write down Maxwell's equation in non-conducting medium, constant permeability and susceptibility or permittivity as it is called. Show that E and B each satisfy the wave equation. Yes. Find an expression of the wave velocity. Write down plane wave solution for E and B. Show that E and B are related. So ये तो first thing which you study in electromagnetic wave, you have to do that. But look at the second question now. This is a like question which requires very detailed analysis of electromagnetic wave. In a partially conducting medium, epsilon r, mu r is given, sigma is given. You have to find alpha, beta, eta. Eta is impedance for the velocity and the velocity u for a frequency which is given. You have to also determine h given that E is given. So E is given to you. E में यहाँ पे alpha है, E में यहाँ पे beta है. You have to calculate all of that. So this is a proper जो भी आपने पढ़ रखा है उसका जो इस्तेमाल है वो करना पड़ेगा. ये easy है. Continuity equation is embedded in Maxwell's equation. One more question which I want to show is this one. This was asked by UPSC last year. ये 2024 का question है. This is again another very good example of practical question rather than standard derivation. A practical question. Plane wave is given, propagates in lossless medium, epsilon r is given in z direction. So polarized along x-axis, see it here, but propagating in z direction. Assume that Ex is sinusoidal with frequency is given, has a maximum value that is also given. You have to calculate E at any t and z. तो पूरा expression लिखना है electric field का. Expression for H and determine the locations where Ex is positive maximum and t is equal to 10 to the power minus 8 second. Okay, let's do at least these questions, if not all of them. तो पहला तो बहुत आसान है. We know Maxwell's equation. question del dot E Gauss's law for magnetism, del dot B is 0, del cross C minus del V by del T Faraday's law, and del cross B mu epsilon, because remember free space नहीं दे रखा है. It is saying non conducting medium rho 0 है, J 0 है, but free space नहीं दे रखा. अगर free space रहता तो यहाँ पे mu naught epsilon naught रहता, ठीक है. But I have written it here mu epsilon del E by del T, which is Ampere's Maxwell law. आप Faraday's law का curl लो, you find this relationship, del 2E is mu epsilon del 2E by del T to 2. Ampere Maxwell law का curl लो, you find this relationship, del 2B mu epsilon del 2E by del T2, and both of this satisfy wave equation, because जो standard wave equation होता है यही तो होता है, del 2 psi is 1 by V square del 2 psi by del 2T, right? And V in this case will be 1 by mu epsilon. For free space that will be mu naught epsilon naught, that is nothing but C, 3 into 10 to the power 8 meter per second. And plane wave solution भी लिख सकते हो आप, and आप पूरा relationship बना सकते हो. I do not want to spend a lot of time here. Okay, let's look at the second question. Now this is a difficult question. This is not an easy question at all. Epsilon r is given, mu r is given, sigma is given, frequency is given, E is given. You have to calculate what is this beta, what is this alpha, what is the velocity u, and based on that you have to calculate what is h. These are the things you have to calculate. ये बिल्कुल ही आसान नहीं है. तो पहले तो आप epsilon निकाल सकते हो. Epsilon will be epsilon r, epsilon naught, mu will be mu r, mu naught. ये हमने निकाल लिया. अब कुछ कुछ चीजें आपको याद रखनी पड़ेंगी. Electromagnetic wave जब पढ़ोगे, you learn about propagation constant, which is shown with gamma, and gamma is alpha plus j beta. Why I am showing j? J is square root of -1, but I am using j here. That is again a very standard notation, because I is very common in electrodynamics. I is electric current, so I do not want to use I for that. So, but remember, j is nothing but, I am talking about a complex plane here. We are talking about a complex number. In terms of angular frequency, permittivity and permeability, this is your propagation constant. सब कुछ दे रखा है यहाँ पे. अब यहाँ पे एक चीज हमको ध्यान रखना पड़ेगा. यहाँ पे आपका जो आपने अलजेब्रा पढ़ा था क्लास 11-12 में, पर्टिकुलरली जो कॉम्प्लेक्स नंबर पढ़ा था आपने, वो बहुत काम आएगा. एंड यहाँ पे पर्टिकुलरली जो आयलर्स इक्वेशन है उसको यूज करने अच्छे से आना चाहिए. दैट आई कैन रिप्रेजेंट एनी x प्लस आई वाई. Why I am mentioning that? That मान लो I have x plus I y, I can represent that as r e raised to the power I theta. याद है हमको? Why I am saying that? कि अगर आपको x plus I y निकालना हो square root, तो just हमको याद रखना है कि this is nothing going to be r e I theta by 2. ये सबसे आसान तरीका है complex analysis का when I do this Euler's relationship, right? So why I am saying that? Because immediately you find that I am finding a square root of -1 plus j. हम इसका मॉड निकालेंगे, r निकाला हमने, that is 1.4. हम थीटा निकालेंगे, theta is -44 degree in argand plane, that is going to be 136 degree. So this is going to be in somewhere in second quadrant. And यही मैं बता रहा था. So I take that square root of r, 6.3 10 to the power 6, 1.4. एंड ये जो 136 डिग्री है उसका मैंने 2 ले लिया, दैट इज 68 डिग्री. तो आई इमीडिएटली फाइंड माई गामा, एंड द मोमेंट आई फाइंड गामा, देन नाउ आई कैन इजिली राइट दैट व्हाट इज अल्फा. अल्फा इज गामा cos 68 एंड बीटा इज गामा sin 68. तो ये मेरे दो वैल्यूज निकल के आ गए. अल्फा बीटा आई हैव कैलकुलेटेड. हमको इम्पीडियंस निकालना है. इम्पीडियंस का जो वैल्यू होता है दैट इज j ओमेगा u सिग्मा प्लस j ओमेगा एप्सिलॉन. अब यहाँ पे भी सब कुछ दे रखा है, बट यहाँ पे भी ये कॉम्प्लेक्स एनालिसिस क्लियर होना चाहिए. अब देखो यहाँ पे क्या है, दिस इज j विच इज e रेज़्ड टू द पावर i पाई बाई 2. रिमेंबर इट इज ऑन दी y एक्सिस. सो यहाँ पे कोई रियल नंबर नहीं है. सो दैट इज व्हाट 90 डिग्री इज हियर, एंड 1 प्लस j 1.03, and that is represented with 946 degree here. तो ये again complex analysis हम करेंगे, बहुत easy है. Do that and your eta value mod eta is 2096. वो भी हमारा निकल के आ गया. So phase velocity is nothing but omega by beta, 2.25 10 to the power 8 meter per second, and h is nothing but 1 by eta k cross e. E is given 50 k is given, z axis के along है. So k cross ay is minus ax. Put all of that and your h is here. This is your final h, right? So ये जो question है यहाँ पे, this is a proper application of details about electromagnetic wave which you study. And one more question before I end this class. By the way, this is very easy. A question ये था that continuity equation is embedded in Maxwell's equation. So उसके लिए मुझे पूरा सारे चाहिए भी नहीं, बस मुझे दो चाहिए. I want Gauss's law del dot E rho by epsilon naught. I want Ampere Maxwell law del cross B mu naught J mu naught epsilon naught del E by del T. अब ये देख लो. Take divergence of 2. Del dot del cross B is del dot mu naught J mu naught epsilon naught del E by del T. Mu naught del dot J. अब del cross B जो है, divergence of curl is always going to be 0. So del dot del cross B is going to be 0, right? So this is mu naught del dot J, and this is mu naught epsilon naught del by del T of del dot E, and from Gauss's law del dot E is nothing but, ये हमने लिखा है यहाँ पे, del rho by del T. So put all of that and you find continuity equation, conservation of charge. The charges are going to be conserved. One more question before I conclude the discussion. This is another question, by the way, about Fresnel's relationship, but this is again a very standard derivation you can find in any textbook, that if I have on a dielectric medium, I have some electromagnetic wave which is it is parallel to plane of incidence. That is a separate case compared to perpendicular to plane of incidence. So a fraction of that is reflected, a fraction of that is transmitted, and you have to find how much is the reflectivity, how much is the transmittivity, and that is Fresnel relationship is. So you have to use again boundary condition जो हमने थोड़ी देर पहले पढ़ा था. Use all of that boundary condition and you find a very nice relationship, and using that you can also calculate what is called Brewster angle. Okay, this is a question I wanted to talk about. This was a question asked by UPSC last year, 2024 का पेपर है. E दे रखा है EXAX which indicates wave is polarized in x axis propagating along z direction. तो ये हमारा जनरल फॉर्म होगा EX ZT E naught cos omega t minus beta z plus phi. अब यहाँ पे हमको सब कुछ निकालना है, जो भी वैल्यू दे रखा है उसके हिसाब से हमको निकालना है. बीटा इज फेज कांस्टेंट, phi is initial phase. So frequency is given. I know angular frequency. I know beta. Beta is nothing but omega by v. V is speed in a medium. अब v क्या होगा किसी भी मीडियम में? v is c by epsilon r and mu r. दोनों दे रखा है, 4 है and 1 है. So मेरा v निकल के आ गया 1.5 10 to the power 8 meter per second. Okay. Maximum displacement, बीटा भी दे, बीटा अब हम निकाल सकते हैं. बीटा is 2 pi into 10 to the power 8 divided by 1.5 10 to the power 8. So beta is calculated 4 pi by 3. Maximum displacement is given 10 to the power minus 4 voltage per meter. तो आप ऑलरेडी देख रहे हो दैट हमारा एक बड़ा नाइस रिलेशनशिप मिल गया. EX ZT 10 to the power minus 4 cos omega t 2 pi into 10 to the power 8, that is the frequency. Frequency is 10 to the power 8. 4 pi by 3 z plus phi. अब phi हमको निकालना है. अब phi निकालने के लिए हम वो एक लास्ट जो रिलेशनशिप दे रखा था, that at t is equal to 0 and z is equal to 1 by 8 there is a maximum displacement which is 10 to the power minus 4. हम सब कुछ पुट करेंगे 10 to the power minus 4, 10 to the power minus 4. t is equal to 0, this becomes 0. 4 pi by 3, 1 by 8 सेकेंड दे रखा है, z is equal to 1 by 8 दे रखा है. यहाँ से हमारा phi निकल के आ गया. So 1 is cos minus pi by 6 plus phi. So phi is nothing but pi by 6. So हमारा रिलेशनशिप एक बढ़िया सा आ गया. That मेरा जो इंस्टेंटेनियस इलेक्ट्रिक फील्ड है वो ये है. So I write this. And फिर जो नेक्स्ट पार्ट ऑफ क्वेश्चन ये है that h क्या होगा. अब h के लिए पहले तो हमको एम्पलीट्यूड निकालना पड़ेगा. तो उसके लिए आई विल यूज दिस रिलेशनशिप E by h is mu by epsilon. Mu epsilon सब कुछ दे रखा है. इससे आप z निकालोगे. z is 188.5 ओमेगा एंड ये एम्पलीट्यूड जो होगा दैट इज नथिंग बट E naught by z 10 to the power minus 4 188.5. And I will mention this, just एक चीज़ जो मुझे करना चाहिए था, which is I have not done here. I have mentioned it only, that wave propagation is towards Z, E is towards X, so H should be towards Y. So ideally, I should mention AY here. AY unit vector I can, or EY unit vector I can mention here. ठीक है? And last part ये है कि EX maximum कौन से टाइम पे होगा, राइट? तो कौन से टाइम, उसके लिए cos थीटा जो है वो 1 होना चाहिए. तो 1 होने के लिए this term should be 0. 13 pi by 6 minus 2n pi should be 4 pi by 3 z. यहाँ से मेरा z आ गया, that all the places where z is 3 by 4, 13 by 6 minus 2n will be the maximum. N is all the positive integer including 0. I have calculated this for 0 also. For 0, so at this particular distance, I am going to have maximum displacement. So this is a very good question, a practical application of electromagnetic wave and the equations which you study. Okay. And one last question, I have some time, I can discuss here is from black body radiation. How does Planck's law resolve ultraviolet catastrophe predicted by classical physics? Calculate the average energy of an oscillator assuming classical oscillator and Planck's oscillator. This is the starting point of quantum mechanics. That when you study the history of quantum mechanics, and then you realize that when black body radiation was studied, one of the most famous laws was Rayleigh-Jean law. But if you plot Rayleigh-Jean law for higher frequency, then it is saying that the radiation density that will become infinite, which clearly does not happen. The radiation density does not become infinite. So clearly this is a problem. In this zone, it fulfills the experimental data. In this zone, not at all, right? So पहले तो हमें diagram भी बनाएंगे कि ये जो पूरा part है, where suddenly that radiation density is traveling towards infinity, this part is not at all possible and of course not observed. So this part is called ultraviolet catastrophe. And ultraviolet catastrophe का जो reason था वो ये था कि classical physics predicted energy density of black body radiation would increase infinitely as frequency increases, and this is what is ultraviolet catastrophe. And this was resolved very nicely by Planck. Planck did not know why it is happening. Planck simply was doing a mathematical trick, and the mathematical trick was that he introduced the concept of quantization of energy. That जो energy होगा वो discrete packets में radiate होगा, and एक packet का जो energy का जो formula है, you can think of that this energy will be proportional to the frequency. So quantization of energy proposed that electromagnetic radiation could only be emitted or absorbed in discrete packets of energy called quanta, and this energy is going to be proportional to nh nu. And this is again a one-page derivation, but it can be calculated that if E is nh nu, then average energy is going to be h nu by kt minus 1. So now there is a function, there is an exponential function in the denominator, and when you plot now, you find exactly what you find in experiments. अब क्वेश्चन में दे रखा है फ्रीक्वेंसी दे रखा है, उसके हिसाब से आपको एनर्जी निकालना है. फॉर क्लासिकल ऑसिलेटर एनर्जी इज नथिंग बट k times t, that is very easy. So in this case that energy will be 0.15 electron volt, and for Planck oscillator energy is h nu e raised to the power h nu by kt minus 1. Put all of that, and energy here is 0.062 keV. Right, and done. So very simple again question of formula putting. You have to remember the formula and you get the answer. This is a topic where you suddenly realize that जो classical mechanics था वो तो पूरा 10 plus maximum 10 plus 2 है, but in electricity and magnetism you realize that yes, you have to work really hard in this particular topic. But this is very scoring part, by the way. If you master this, if you practice it really well, and good candidates will choose this question. This part is much more scoring than thermodynamics and statistical physics. Okay. If you have doubts in any of this topic, you can send me a mail. I've also seen that the solution of the previous discussion is not available. So I'm going to get this solution available in the video description when it will be uploaded. And I will do that also for the other 2 topics. Okay. All the best, guys. We'll have a discussion on Saturday on nuclear and particle physics.